Okay. Okay. So, good morning again. I didn't open the apa nama tu kamera just apa to lain dekat rumah tak aku sangat. Okay. Kita putus-putus. Okay. So, for topic for this morning, we're gonna cover the software project management. So, if we this is the topic that we are supposed to cover on based on the body of knowledge of software engineering. So, team participation, uh, yeah, involved on the team process, participation, roles, responsibility, semua tu lah. Okay, conflict resolution, that one we're gonna discuss later. With the risk associated with virtual team. So now because of the pandemic, everything is done on with virtual. Even if you do the project, previously pun virtual juga kan, you can contact with the friends and everyone. So this is the part they're gonna discuss later. And then we'll look into at the effort estimation, risk, the role of the risk in the life cycle, and some more on risk lah. Okay, so this is the part they're gonna cover this morning. So before this is the how your SDLC, your life cycle of your software is supposed to be look like. Okay, it's supposed to be this is on book lah, requirement analysis, the design, implementation, testing, and delivery and installation. Okay, so this is how it's supposed to look like. But when you do it, this is how it look like. Okay, I think in your FYP also it's this is what happened lah. You get all the requirement analysis, you do all the requirements. This is the thing. This is the thing uh, that you need to do in the system, and then when you start doing it, the delay dekat situ, and then at the end nanti dia hilang. Okay, so sometimes it look like this. Okay, if the perfect, it's supposed to be like this, but then sometimes this happen. Okay, because of a lot of things when you do the design, when you do the implementation, and so on inside there, but a lot of other things happen and you keep on going around and around and around, and then you delay. Okay, so that is things that usually happen. It's normally not normally lah, sometimes happen. Okay. So if you look at the what is the software project, it's all the technical and managerial activities required to deliver the deliverables to the client. That is the project lah. Okay. So you need to have a specific duration. You will consume the resource for you to do the project and to produce it. Okay. So the management activities include for you to project to assign or come up with the tasks, the activities, and the function that you're supposed to do for the project. Okay. The management plan, the project itself is the project lah, and then you need to plan how you manage your project. Okay. So you need to have the documents for the project. So you cannot just like do it without on any documents. So you need to have the controlling document so that you know what to do, what is the boundary, and so on. Specify the technical and managerial approach to develop the software project. Okay, so you need to know also the technical part. You need to put it on paper so that when you do the thing, you know what to do, and you can do it faster if you have everything on paper rather than just have apa, or you just talk to other people. Then sometimes it's lost in apa, communication, the information. You will need also a companion document to requirement analysis document, which is the changes in either may imply changes in the other document. So if you need to have a few of other documents. Okay, so that and if you have changes in one part of the thing, you need to also change in the other document. So SPMP may be part of the project agreement. Okay, SPMP is our project management plan. Okay, so the document itself. So you can the document itself can be part of the project agreement that you agree with client. So you said this is the thing that we're gonna do. This is the part, the technical part. This is how we're gonna manage it. so that you can do the complete the project successfully. Okay. The project agreement is the document written for client that defines the scope, the duration, the cost deliverables for the project, and the time, quantities, delivery dates, and location. Okay, so the project agreement is important because when your client asks you to do something, it's involve money, and you want to you need to have the document that so that you have a clear uh, information or clear all the information needed to be done so that when you deliver, the client will not say that I didn't ask you to do this thing and I want to pay you or something. Yeah, or he said you need to put the inside the agreement also like when you are expected to deliver and so on. Okay. So when you have this document, for example, maybe they ask you to install it at one place. So if you don't have the exact delivery location, maybe when it's time come in 1 year when the project is up, and then they ask you to do that other place also. So that is the thing that why you need to have a project agreement so that all the information is clear on what to do, when to deliver, and so on. Okay, so the project agreement can be a contract, a statement of work, a business plan, or a project charter. Okay, for client, can be individual organization that specify the requirement and accept the project deliverers. Okay, so the client is the one who give you the requirements or who give you the information on what he wants to be in the system, what he requires to be in the system, how he wants the system. Okay, so and he is also will be the one who will accept the project when you deliver it. Okay, so deliverables are equal to the work product that will be delivered to the client. Okay, so that is the deliverables. It include the documents, the demonstration of function, how it works, and so on. You need to do the demonstration to the client. Demonstration of non-functional requirements too. Non-functional requirements like the system and so on, the hardware and so on, and the demonstration of a subsystem if you have. Okay. This is the project agreement versus problem statement. So if you look at the project agreement is in between the client and manager. Okay, and only the manager for this one is in between client and manager. Okay, so the client will state will inform the problem statement to the manager, and the manager is the one who gonna software project management plan, discuss the software project management plan. He is the one who gonna discuss it with the project team. Okay, so and the project agreement is between manager and client. So it's going back. So from manager to client, problem statement is from client to manager. Okay, so this is the project agreement problem statement. This is the project management activities. When you get the project or when you acquire a project from client, so what are the things that you need to do first is you get the information from a statement definition. So, for example, the client said, I want you to come up with a system for me to manage my customer, for example. So that is the problem statement. And from that problem statement, you need to this is the process for you to complete the system. Okay, so initial top level design. So you just put the top level and the initial milestones planning. Uh, Yes, sir. Can I, can everyone hear me? Or is it my template? Okay, okay. Maybe the connection. Yeah, the my internet line yesterday at office they also have problem with the internet, so that's why I don't because we are still work from home. Okay, and the internet at my home is they changed they are fixing the road in front of our house, so now I have to use my phone internet. That's why the line is supposed to be stable lah. Now udah okay ya? Okay, okay. So I just sambung ah. Okay, so if it's putus-putus, you just mention on apa? Chat nanti saya cek the line ah. Kalau terputus tiba-tiba kan. Okay, so again, come back with we look at this again. Okay, so this is the initiation phase when you get the contract or when you get the project from the client. So you need to do the problem definition and so on. Okay, and then this is the steady state. Okay, so when you already get the project agreement, and then you study the risk, you monitor the status of the system or the project while your apa, team are doing it. So sometimes, for example, the risk management here, one of your main programmer quit, for example. So you need to do the project replanning. Okay, so the project replanning can include extra time, for example, or you need to look for new team, or you come up with you ask the previous person to replace the quit member, the member who quit, for example. So that is the project planning and project agreement. Also, you need to come up with the document this time, okay, in a steady state, because you come up with project agreement during this time because you already know the risk. So when you study your risk management, you know that if this thing happens, so it will take this time, how long the time for you to have to complete the system. So you already have your contingency plan, you already have your backup plan, and so on, if anything happens. So that is the thing that you put in the project agreement. Okay. And then after you finish everything in the steady state, then it's a termination state where you do the installation, meaning the system already complete, your project already complete. So you do the installation at your client's place, and then the client test the system, okay, and then after the client acceptance test, they do the test and it's okay. Then you do the postmortem. Anything come up, you need to do the postmortem for every project you have, so that you can learn from it. For example, the things that you can learn from the postmortem is, for example, you take so much time to do something, and that is the thing that you need to look. If you have another project, then that things should not be happening. Okay, so that is why you need to do postmortem for every project. Okay, so you need to look at lesson learned and so on. Okay, um, project function activities and tasks. This is the how you divide the project when you get the project. So the project can be divided into function, into activities, and each activities can be also divided into tasks, smaller tasks. Okay, so um, if you look at the function part, okay, so activities or set of activities that span the duration of the project. Okay, so a function is the apa uh, function is the big part of the project lah. Okay, so function will be divided into activities, and activities will be divided into tasks. So for this function, um, set of activities that span the duration of the project. So for how long your project run, you will have to check your function and so on. This is the main part that you do in the project. Okay, so Example of function is project management, configuration management, documentation, quality control training, and so on. Okay. So, for example, you have the system question is system integration a project function. System integration project function. Okay, so you need to ask. Okay. And then the mapping of terms project function in the IEEE 1058 standard called integral process and in IEEE 1074 standard. Okay, so we call them the cross development process. Okay, that is the project function. So it's cross development. So the whole development you are doing the this thing. Okay, so if you look again, the duration of the project. So from the beginning of the project until the end of the project, you need to do all these things. Okay, training, quality control, and so on. Okay, the next one is the task. Okay, task is the smallest unit of the work subject to management, small enough for adequate planning and tracking, large enough to avoid micromanagement. Okay, so this is the task. Okay, the smaller part of the task. For each activity, you can have a few tasks. Okay, so task is smallest unit of management accountability, atomic unit of planning and tracking. It can have definite duration. Okay, need resources, produce tangible result. For example, the document, the code. Okay, so the task is small compared to function. It's part of the function, part of the activity. Okay, specification of tasks. You need to come up with the work package. Okay, so you need to have the name, description of the work to be done, precondition for starting, the duration, the required resources, work product to be produced, what you're gonna come out with at the end of the work, okay, at the end of the task, acceptance criteria for it, okay, and the risk involved. Okay, so that is the specification of the task that each task need to have this work package. Okay, so that if you are given this task, you know what to do. Okay, what work to be done, what should have or before you do it, and what the output. Okay, at the end of it, and the risk involved. Okay, completion criteria includes the acceptance criteria for the work product. So the acceptance criteria you need to specify the that's why you need to specify the acceptance criteria. Okay, so that when you successfully do the acceptance criteria, then you know that it's complete already. Okay, so include the acceptance criteria for the work products that were produced by the task. Okay, so that is for task. And then task size, find the appropriate task size is problematic. So uh, um, each project have different type of things that you need to do. So the task size is also hard to apa tu decide what precise or how big it can be for each task. Okay. But the way you can do it is by looking at the to-do list from the previous project. Okay, so you know that if you have to do like the user, for example, user registration task, for example, you know that it will take one person to do it, for example. Okay, so you based on your experience, you know is it the suitable size or not. Okay, so during initial planning of a task is necessarily large, usually you may not know how to decompose the problem into tasks at first. Okay, but when you are in the halfway of doing it, or you already know the initiation and parts, then you know after you learn more about the task, then you know how big it is. Okay, each software development activities identifies more tasks and modify existing ones. Okay, so that is what they do. They identify uh, more tasks and modify the existing one so that the existing one, they can divide it into smaller tasks if needed. Okay, tasks must also be decomposed into size that allow monitoring so that you can if it is too big, you don't know whether when you ask your workers under you, for example, have you done this task? And then because it's too big, um you don't know where he is now. He said I'm in the middle of it, for example, but you don't know which middle because the task is so big. Okay, so that's why you must be decomposed into size that allow monitoring so that Okay, where are you now? If the user, your programmer can say, I've already done this part, and this part is not. So that if it's small enough for you to monitor, that you know that, you know a specific size or a specific uh, time that you can finish it. Okay. It also depends on nature of work and how well task is understood. Okay. So that is for task size. So for example of task, this is the example, unit test class 2, for example. This is the example name that you can put of the task name lah. Okay. And then you test the subsystem blah, for example. Uh, and then this is some of the other example lah. Okay. Write user manual, write meeting minutes and post them, write a memo and edit and unique schedule a code review, develop project plan and so on. Okay. So this is the example of task. Action item, the last one, action item is definition for action item is a task assigned to a person that has to be done within a week or less. Okay, so that is a thing that you need. If it is action item is need to be done immediately. Okay, action item appears in the agenda in the status section. This one is the so it covers what, who, and when. Okay, so what to be done, who gonna do it, and when you want it to be done. Okay. Example of action item is Florian unit test class 2 by next week. Okay. So Florian need to do the unit test for class by next week. Or Marcus develop a project plan before the next meeting. Or Bob post next agenda for the simulation meeting and so on. So everything develop project plan by September 18th. So that is the action item. Okay. And then we look at the activities. Okay, so we already look at function, we already look at task. So for activities is the major unit of work precise with precise date, consists of smaller activities or tasks. Okay, and apa tu culminates the in project milestone. You need to put it in a project milestone. Okay. So major unit of work terminate in major project milestone. So you need to put the internal checkpoint should not be externally visible, and schedule even used to measure the progress. Okay, so you have to measure the progress. Can often produce baseline, formally review work product under change control. So this one is change control requires a formal procedure how you manage the change control. So the activities may be grouped into larger activities. Okay. So establish a hierarchical structure of project. So into phase, into step, and so on. Allow expression of concern. Precedence relation among existing often exists among activities. So you need to come out you look at your PERT chart. Okay. So that is for activities. Example, for major activities planning, requirement station, requirement analysis, this is more to on the phase of your SDLC, okay, system development life cycle. Okay. So system design, object design, implementation, software testing, on. And the smaller part, activities during the requirement analysis, for example, refine the scenarios, define use case model, define object, dynamic user and design user interface. So that is the part that you can categorize as activities lah. Okay. Next one is the structure of the software project management plan. Okay. So the SPMP software project management plan is a document that you need to come out with. So in this document, this is the thing that you need to put into it. Okay. So when you do your system, you need to have this one, the plan for the management plan, how you manage the system project development, software development. Okay. So the front matter, this one is your front part, your the muka depan lah. Okay. So you need to have title page, revision sheet, preface, and tables of contents, figures, and so on. Okay. So this is the front page of your SMP, SPMP, software project management plan. And then you need to have the introduction part, okay, overview, so summary, describe a project, product summary, and then you have the project deliverables or item to be delivered, what are the item, what is the requirement, and so on, including delivery dates and location. Okay, can you hear apa? Oh, disconnected sekejap tadi.
Yes, madam, I can hear you.
Okay, sorry. Okay, so we just continue where we stop. I think I stopped here just now, right? Oh, where did you lost me just now? Before this one? This one. Okay. So again, I've talked about the structure of the software project management plan. This plan is a document, okay, that you need to come out at for your project. So for each project, you need to have one project management plan. Okay. So that's why if you look at this is the thing that need to be included in your project management plan. Okay. So it will have the front matter, introduction to the organization, managerial process, technical process, work element, schedule, budget, and optional inclusion. Okay, so for the front part, for the front matter, this is of your front page, first few page of your project management plan. You need to have the title page, the revision sheet, preface, table of content, figures, and tables. Okay, so this is your front part, and you're gonna have the introduction part. Okay, so project overview, you need to have the executive summary of what the project about, description of the project, and the summary of the product. Okay, and you will also have the project deliverables because this part, this document SPMP can be part of your project agreement with clients. So you need to also show right inside it all the items that will be delivered, including the delivery dates and location where you're gonna deliver the project, where you're gonna install the project, for example. Okay, so that is in your project deliverables. Evolution of your SMP, SPMP, plan for unforeseen and unforeseen change. So, uh, um, so uh, if there is a change, so you need to have a plan for it. If you have like the changes of manager and so on. Okay, so you need to include it in your report or in your project management plan. Okay, and you also have to include your reference material, which part in all the documents that are or reference inside your SPMP, the documents. Okay, definition and acronyms similar to when you do your FYP lah, all the reference definitions. Okay, process model. This one is the project organization, how you organize a project. So you need to have your process model. Okay, relationship among project element, organization structure, organizational interface, and project responsibilities. Okay, so for the major function activities, nature of each, how you're gonna do it, who is in charge, and so on. Okay, so this is the project organization part, the second part of your SPMP. Um, the process model, okay. The first one, the process model shows relationship among function, activities, and tasks. Okay, the milestones, the baseline, the reviews, work breakdown structure, project deliverables, and sign off. Okay. And then for visualization of the process model and the project management aids, you can use Microsoft Project or Mac Project or EasyTrack. Okay, so this is the one that you can use for your project management. Okay, the software that you can use. For the organizational part structure, this is the example of your organization chart that you can include in your project management plan. So you have your client, you have the management, and you have the consultants who discuss with the client. Okay. And under the management, you have the cross-functional teams and the development team. So development teams will have to need all these document, logbook, the maintenance, the vehicle, the travel, VIPs. Okay. And for under the cross-functional team, architecture, HCI, webmaster, documentation, duration management, and so on. And under this management also, under this team also, you're going to have the infrastructure team. Okay. Okay, so this is the organization chart example. And then you're going to have also the project roles. You need to have the project roles also for each and one. You're going to have a planner, analyst, designer, programmer, tester, maintainer, trainer, document editor, webmaster, configuration manager, group leader, liaison, minute taker, project manager. Okay, it doesn't have to be one person for each of these. It can be one person doing some of these. Okay, so management roles uh, for the project role, organization and execution of the project within constraint. For example, the project manager and the team leader. So that is the management. They are the management. Okay, so and they look at the constraint and so on. Development roles is the one who do the specification, who do the design, construction of the system, and so on. Okay, so analyst, system architect, implementer is the development, the one that do the development roles. Okay, cross-functional roles, coordination of more than one team. So for example, API engineer and configuration manager and tester. Okay, so they can do this one can be one person, for example. So they cross-functional. They don't only test or they don't only look at one function, but they can look at the overall system. So for example, the tester they test the function and they test the overall system. So that's why they are cross-functional roles. They have the cross-functional role. Okay. Consultants role support an area where the project participation is lack expertise. Example, end user, client, application domain specialist, technical consultant, and so on. And also the promoter's role, promote change through the organization. So if there is a change, they need to tell everyone in the team that this is the changing that we are doing. So that is the promoter role. Okay. We look again promoter roles. They are self-appointed individuals who identify themselves with the outcome of the project. So member of the corporate organization may not necessarily be directly involved with the project, but they can also they are interface to the rest of the corporate organization. Yes, so that is the promoters. Because of power, knowledge, and technology or familiarity with project processes, they are able to promote and push specific changes through the organization. Okay. So can be someone at the top that want you to do something or some project in some similar way, okay, or some way that they want you to do. So the promoter's role need to be somebody that can do all of these things. Okay, they can push the specific change to the organization. Okay. Power promoter also called executive champion pushes the change through existing organization hierarchy. So not necessary at the top of organization, but must have protection from top management level. Okay, so this is the power promoter. Otherwise, project opponents might be able to prevent the success of the project. Okay. The task of power promoter constantly identify difficulties, resolve issues, and communicate with project members, especially with the developers. Example at project level is the project manager. Example at corporate level is the CIO, the CEO, sorry, chief officer. Okay, so that is the power promoter. So they can use the power to change something or when I want to do something so that the system will be a success. Sometimes they see it from overall picture of the project itself. Okay. Knowledge promoter, also called the technologist, promotes change arising in the application domain or the solution done, usually associated with the power promoter. Okay. The tasks include acquire information iteratively, understand the benefits, limit the new technologies, and argue its adoption with other developers. Okay. And then example at project level is the system architect because he's the one who knows what how the system gonna look like. Okay, how you gonna do it. So the system architect report to project manager does not have any direct subordinate in the reporting hierarchy, has final say over all technical decision in the system. Okay, so he's the one that they call the knowledge promoter because he knows what is inside. Example at the corporate level is the chief technical officer. Okay, usually the one with knowledge is the technical officer. Okay, the CEO sometimes he knows the overall picture, but I don't know what is inside the system itself. Okay, so in corporate level, the chief technical officer is the one who knows you have the knowledge about the system, the detailed knowledge compared to the knowledge to the power promoter. Okay, process promoter. Process promoter has intimate knowledge of the project processes and procedure. Process promoter constant interaction with the power promoter and get consensus on the overall goals. Okay, so task for this process promoter is to bridge between the power and knowledge promoter who often do not speak or understand at the same language. Yes. So the process promoter is a middleman between the management and the knowledge promoter. So example of a project level is development lead, responsible for the administrative aspect of project, which include planning, milestone, definition, budgeting, and communication infrastructure. Okay, so that is the example at corporate level is chief information officer. Okay, so more to information. It's not technical, but the information CIO. Okay, so this is the project management hierarchical project organization. Control flow, information flow. So you see the top one is the chief executive. The three middle one is the first level manager, so the front line manager, and the bottom part is the project members. Okay. So for example, if A wants to talk this A, okay, want to talk to B, complicated information flow. If you look at this one, because you need to be going on the top and so on. So A want to make sure B does something change, complicated control flow, for example. Okay. So if you look at this one, basis of organization, complicated information and control flow across hierarchical boundaries. Okay, so it even though you want to talk from A to B, they are in the same level, same hierarchy as a project manager, but if you level to the executive, then you can convey the information to B. Okay, because you don't only communicate change or between you among yourself, otherwise your management or the chief executive would know what happened on the bottom part. Okay, what happened on the ground. Okay. Example again, chief programmer team. You have the chief programmer, assistant chief programmer, and you have senior programmer. This one is the one librarian, engineer, tester, and you have the junior programmer. Okay, so this is the example of organization team. Okay, another example, analyst, tester, designer, librarian, and programmer. This one is among themselves ego-less programming team. You cannot be ego because all are the same. There is no hierarchy in this one. Okay. This one is project-based organization. Again, similar to the previous one. Uh, project leader on the top, coach. So all the line is the communication of between them. Over here, you can see that A can talk to B. Okay, communication flow, decision flow. Okay, the decision flow is the B one. Okay, in previous one, decision and communication flow is complicated because you need to go through all the management. Okay, executive, the first level, and the project members. Okay, but for this one, communication flow is only between A and B. Okay, non-linear information flow across dynamically formed units. Okay, so this one is project-based organization. Association in organization structure. Um, Reporting association used for reporting status information. Decision association used for projecting propagating decision, and the communication association used to exchange information. Okay, so this is the association that is used in the organization structure. Okay, how one part associate with one another. Okay. If you observe the management structure, hierarchical structure, report, decide, and communicate with all mapped to the same association. Do not work well with iterative incremental software development process. So this use is in SDLC. Okay, and also management manager is not always right, not necessarily always right. Okay, so for project-based structure, report, decide, communicate with different association. Cut down the bureaucracy, reduce development time. Decisions are expected to be made at each level, but it is hard to manage. Okay, so this is the one that I talk about is this one compared to this one. Okay, this one is hierarchical. This one is project based. Okay, so if you look, manager is not necessarily always right because every decision manager needs to know. Okay, um, it is and experimental software development is not because you will need to go to through management and do the iterative processing that approach. Okay, hierarchical structure. For project-based structure, you cut down the bureaucracy. So because you direct communicate with between A and B, you talk directly. without the going through management and the CEO. Okay, the decision are made in each level. So for for the team members, they can decide among themselves for any decision. Okay, and but it's hard to manage because the manager would know what happened on the ground. Okay, that is the difference. Project with high degree of certainty, stability, uniformity, and reputation, you can use the hierarchical structure. Requires little communication, role definition are clear. So when you can use the hierarchical structure, the more people on the project, the more need for a formal structure. Okay, customer might insist that the rest of the team be independent from the design team, and project manager insists on previously successful structure. Okay, so this is when they will want to use the hierarchical structure. For project-based structure, um, project with degree of uncertainty. Open communication needed among members so that they can decide on the ground level. Roles are defined on project basis. When you can use the project-based structure, requirements change during development and new technology develops during project. So that is when you need to do the, or you can use the project-based structure. Okay. This is how, this is task that you need to do to assign the project, assign the responsibility to people. Okay. For example, you have team A, they have two person here, person A and person B. So you give a role to person A, role 1 and role 2, and role 3 to person B, for example. And for each role, they have the item that they need to do. Okay. So for example, person A have to do 1, 2, 9, 4, 7, 4, 5, 7, and person 2, person B need to do the 3, 6, and 8 item. Okay. This is this document you also this information you also need to document it so that when when something happen or something wrong with item 6, for example, you know how to look for. Okay. Response possible mapping of to do to people. It can be one-to-one idea, but often not worth to be called a project if it's one-to-one. Okay. Menu to view, each project members assume several roles, danger in overcommitment. Okay. So if you ask the one person to do a lot of things, he might not able to finish the work. Okay. And then need for load balancing. Okay. So that some people got, all of them got enough or got the same load. Okay. Many to too many, some people don't have significant roles, some become bystander and losing touch in the project. Okay. So if you have if you have a task and you give it to too many people, then it's like when you do your group project lah, ada yang jadi pemerhati saja, bystander. Okay. So you need to have enough mapping for everyone to do enough enough tasks for each of them. Okay. And then you also need to form a team information. Um, it depends on the how you design the top level design, rough subsystem decomposition before requirement analysis done during pre-development phase. So the team formation is done after the top level design. Okay, because you already have the design and you when you look at it, you know how many people or who you need in your team. Okay, or you can use the heuristic, one team for each. This is how you decide, one team for each subsystem, one cross-functional task per team, and 5 to 7 members per team. Okay, so be prepared to iterate the team formation after system design when system decomposition is baseline. Okay, so when you this one is the first task when you team form your team, and then after that you can add more or change or so on in your team. Okay. Project roles, you're gonna have coach, listen to groups from individual teams, review weekly team report, attend weekly project meeting. Okay, the coach schedule and prepare meetings with client, insist that guidelines are followed, assign presentation, uh, and resolve conflict if there is conflict that need to be resolved. Okay, so that is project roles of coach. Group leader responsible for in intra-group communication. That is the group leader. So you can go to meeting management and he's the primary facilitator. Okay. So what the group leader do is run the meeting, post agenda before meeting, what need to be discussed in the meeting, keep define and keep track of action for each item. So who's doing it, what are the items, and when it need to be done. You can also group leader also measure the progress. So they enforce milestone. You keep on going to the team member and said, okay, we need to finish this by this week, for example. Okay, deliver work package for the task to the project management. Okay, when it's done, so I deliver to work management. Present problem and status of team to the project manager. So group leader is the facilitator or communicator between the team member and the project manager. So the group leader has to be rotated among members of the team. Otherwise, if it's only one person, we don't know whether he's gonna be uh, biased with the team member or not. So that's why they need to rotate it so that everyone can be a team leader. Okay, group leader. Group leader need to create an agenda for the meeting. Purpose of the meeting, get outcome, information sharing, information passing, and meeting critique. Okay, so action items, check previous meeting, issues, check previous meeting, and what. Okay, so this is the agenda for the group discussion. Okay, so when you have a meeting, you need to have agenda. Okay, otherwise, if you don't have agenda, you will talk about a lot of things, and then the meeting will run a lot of time. Okay, so that's why you need to have an agenda and just stick to agenda when you do it. Okay, another role is the liaison responsible for intergroup communication. Okay, so make available public definition of such system developed by the team to the architecture teams, ensure consistency and so on, coordinate task spanning more than one group with other teams, responsible for team negotiation. Okay, like middleman lah, liaison. Okay, example is API engineer, configuration manager. Okay, and we also have planner, plans and track the activities of the individual team and has the following responsibility. Define project plan for team. So you're gonna have the PERT chart, resource table, and Gantt chart showing work package. Okay, so planner ni kerja dia plan sajalah. Okay, enter project plan into project management tool. Okay, and then make project plan available to management so that management can keep track. Report team status to project manager. Okay, no explicit planner in paid. Okay, responsible assumed by coaches. Responsibilities assumed by coaches. Okay, that is the planner, and then you have the document editor. Okay, um, everyone do the document, some part of it. For example, if you do the coding part, you need to have the uh, document for to explain that part, but you're gonna have one document editor. Okay, so you need to collect, proofread, and distribute team documentation. Submit team documentation to architectural team. Collect agendas, tag names. So that is the document editor. You also have the webmaster if you do the software development. Maintain team homepage, keep track of meeting history, keep track of design rationale. Okay, that is the webmaster. Okay, you don't have to your project. It doesn't have to be a webmaster, but no, the sorry, your project don't have to be a web system, but sometimes you have a webmaster to where everyone can go and look at the information in there. Okay, so this is the use of the webmaster. So webmaster publish meeting information on team homepage, must contain agenda, minutes, action items and issues, possibilities, one HTML document for meeting, okay, for document for agendas, minutes and so on. So example of this lah, okay. So you have meetings, agenda, minutes, action and issues, okay. The third part of your document is in SPMP is the managerial process, okay. So in manager process, you need to include the management objectives and priorities, uh, philosophies, goals, priorities, and also assumption, dependencies, constraints. Okay. You can include external factors. Risk management, you need to identify the risk, assess it, track it, and what if the risk happen, what you're gonna do, consequences. Okay. Monitoring and controlling mechanism, reporting mechanism, and formats, information flow and reviews, and the staffing plans. Okay. Needed skills. So what, how much, when, who. Okay. So that is your managerial process. Okay. So part three. Example assumption that can be included in your um managerial processes. 3.2 is there are enough cycle and development machine. Security will not be addressed. Okay. There are no bugs in strategy or case to recommend a project demonstration of standard. For example, like this one is a system will be given by the client. This is all the assumption. Okay. Okay. So you assume that the demonstration system will be given by the client and so on. So this is the thing that you need to include in your managerial, so that the assumption you assume, so that the thing that you are not given specifically is not a task, but you need to assume that this is what is gonna happen. Okay. Example of dependencies, database team depends on the APC database provided by themselves. For example, the automatic code generation facility in the case tool depends on JDK. The current release of the JDK support only JDK 1.6, for example. This one is the thing that you need to include. Okay. Constraint, the length of the project is 3 months, limited amount of time to build the system. That is all the constraint of project constraint consists of beginners. It will take time to learn how to use the tools. Not every project member is always up to date with respect of the project status. The use of XML and case tool is required. New code must be written in Java and so on. Okay, so this is all the constraint that you need to specify in your manager process document. And also you look into the risk management. We're gonna talk more about risk management later. I'm gonna give a lecture in the later after this on the risk management. Okay, so your risk member is in a key role drop the cost. Okay, meaning that the apa your one of the member quit, for example. So your contingency of your plan to solve the problem is roles are assigned to somebody else. Functionality of the system is renegotiated with the client. Okay. Or some other risk is the project is falling behind schedule. So contingency extra project meetings are scheduled. One subsystem does not provide the functionality needed by another subsystem. So what you need to do if it's not provided the functionality, you can delete or ask somebody else, look for somebody that can do the function. For example, another risk is a button runs only with JDK 1.2. So what you need, okay? This is all the risk that you need to study and how you're gonna solve it if it's happened. The part 4 of your SPMP is the technical process, method, tools, and techniques, completing the system, the development method, system structure, and so on, and the standard and guideline and policies, okay, for your tools and techniques and methods. And in the technical process also, you need to include the software documentation. So the documentation plan, including milestone review and baseline, and project support function. So plan for function, include quality assurance, configuration management. Okay. The part 5 is the work element. um, the work element have 5 items that you need to put into work package. So the work breakdown structure, project decomposed into tasks, definition of each task. Okay. Dependencies, precedent, relationship among function, activities, and tasks. Resource requirements, budget, and resource allocation. Resource requirements, estimate for resources such as personnel, computer time, special hardware, support hardware, and so on. Okay. And then budget and resource allocation, it's on cost to the function, activities, and tasks. How much it costs you to do some function, some activities, and some tasks. Okay. And also the schedule. Deadline, accounting for dependencies requires milestone. Okay, so when you're gonna finish, when you're gonna start do the next task, and so on. For the first part, for the work package, uh, tools they can use for package is the visualization aids, for example, the graph tables and so on. Task timeline, you can include Gantt chart, okay, and also the project chart. Okay, so this is the one that you can include in the work package. Okay, how do you become a good project planner? Establish a project plan. Okay, start with a plan based on your experience with the last project that you have. Keep track of activities and their duration. Determine difference between plan and actual performance. Okay, make sure to do a post-mortem, lesson learned, ask developers for feedback, write a document about what could have been improved. Okay, so that is the project planner. Okay, for project management heuristic, make sure to be able to revise or dump a project plan if the complex system development is a non-linear activities. You cannot hear clearly. Is it putus-putus or just not clear?
Okay je, madam.
Tidak.
Maybe connection Siu yang ada masalah
Uh,
sikit.
okay, okay. I just continue. If the connection is not good, later I'm gonna give the slide and also I'm recording this. Maybe they're gonna share the recording lah. Okay, for those who don't have a good line, a good connection. Okay, so that you can, if you want to watch again, I'm not sure whether you want to watch again. Okay, but just in case lah. Okay, so project heuristic, project management heuristic. If project goals are unclear and complex, use team-based project management. In this case, you can avoid Gantt chart and PERT chart for the project, and don't look too far into the future. Okay. Avoid micromanagement in details. Okay. Don't be surprised if current project management tool don't work. They were designed for project with clear goal and fixed organization. Which one if you have a very big project and it's non-linear activities. Okay. For summaries of the project management, get agreement among customers, managers, and teams on the problem statement, software project management plan, project agreement. Make sure agreement follows for iteration, organization structure, SCPMP, project planning, tools and techniques. So this is the thing that we discussed just now. Okay. Okay. I'm gonna have a discussion that that you can do. Can someone give me the answer? How you resolve team conflict? And this is based. You can answer this one based on your experience in your class. For example, you are in a group project and some of them gaduh. How you resolve it, and also what are the risks associated with control team in terms of communication, perception, structure. So now everyone work from home, kan? So you are all virtual teams in your project in when you're doing project in class and so on. So what are the risks associated based on your experience? Anyone? Boleh answer? Can write in chat. I can read it. Okay. Have a meeting with who involved in a conflict. Risk virtual team. Not everyone have lecture to online every time. Yeah, that is the risk. No? Any more answer? Okay, I just some of the risk virtual team. Sometimes we have to guide the leader on organizing the team as a whole. Yeah. Okay. So another ways another team conflict resolution is you need to create a healthy culture. So meanings that you don't you don't create a you don't fight with your team members, for example. So every time you have a conflict, just slow talk, treat everyone fairly. Don't treat because someone is knows more. Don't treat him special other than those who don't know much and so on. Okay. Learn to spot the early sign of conflict so that you can for example you have four members in a group and you know that these two person is doesn't like each other, for example. So if you assign a work, for example, you don't group them together, or you group with other people, and otherwise they don't like each other, you team them together and the work will not be complete. Okay. um and you also deal with conflict promptly, develop rules for handling conflict, and never as a leader or as a if you want to solve a conflict, never take side. Okay, you always be a middleman. Sit in the middle of the atas pagar. Okay, you don't say this one person right, you don't say this one person wrong. Okay, but you solve the problem. Okay. Um, risk virtual team, like I said just now, the online sometimes communication you cannot communicate because it's like like if like now I'm teaching you, I cannot see you, I cannot like if I ask you everyone keep silent, unlike in class I can just say you answer it. I also like if online I also cannot ask you the question, I ask somebody to answer because I don't know whether his internet is on or not, whether he has a microphone on or not, and so on. Saya selalu okay. Agent uh, this video is on effort estimation. Ay, putus-putus lagi kah? Sekejap ah. My internet mengong. Wait ah. Can hear or not the... Sekejap ah. I forget to click on button.
A software development project is for the
Can hear or not?
salaries of the development staff. Effort estimation involves approximating the level of effort needed for a project in terms of person weeks, person months, or hours. When person months are used, the average monthly salary of a software engineer person months is the dollar amount the project costs. If 10 person months are estimated and the project timeline spans 5 months, then the estimate would cover 2 full-time development staff members. Effort estimation is needed for project managers to plan and schedule project activities. The effort estimation approaches discussed in this lecture are function point, Kokomo 2, Delphi estimation, and Agile estimation. Function point analysis is a method of breaking systems into smaller components that are easily recognized and evaluated. A function point is a software unit of measurement. Advantages of the function point method are estimation can occur early in the life cycle, non-technical persons can apply the method, and it is independent of the programming language. Disadvantages are it is considered subjective, and for some projects, the category counts are not easy to gather early in its stages. System functions are separated into 5 categories: user inputs, user outputs, user queries, files and database tables, and external interfaces. The counts of these categorized functions are recorded. A complexity is assigned to each count, and a gross function point (GFP) is computed, which is the sum of the 5 counts multiplied by the complexities. For instance, if the number of external interfaces is 4, the number of files and tables is 30, the number of user queries is 8, the number of user outputs is 5, and the number of user inputs is 10, and all complexities are simple, then the counts times the complexities are 30, 20, 24, 210, and 20, respectively, and the gross function point is 304. Then 14 processing complexities are determined by ranking the influence of the 14 characteristics from 0 to 5. A characteristic rated 0 has no influence on the system. A ranking of 5 is essential to the system. This is done by answering the 14 questions shown and concluding the effect of the process on the system through process complexity rankings of 0 to 5. The processing complexity adjustment is computed by using the processing complexities. The formula is 0.65 plus 0.01 times the sum of the 14 processing complexities. Then the function point fp can be calculated, which is the gross function point times the processing complexity adjustment PCA. If PCA is 46 and function point is 13,984 function points, and the productivity of one developer is 60 function points per week, then the effort is the function points divided by the productivity, which is 233 person weeks. If the team size is 5, then the project duration is the effort divided by team size, which equals 233 person weeks divided by 5 persons, having a duration of 46.5 weeks. Constructive cost model (COCOMO) is a procedural model for estimating effort, cost, and schedule. COCOMO was developed by Barry Bean in the late 1970s and published in 1981 in Dr. Bean's book Software Engineering Economics. COCOMO 2, developed in the mid-1990s and published in 2000, is an update to Kokomo 81. Kokomo 2 takes modern coding practices into consideration: code reuse, desktop programming, and commercial off-the-shelf software. Kokomo 2 consists of 3 models. The application composition model is used for building prototypes in the early stage of the lifecycle. The early design model is used during the early stage of a project. The post-architecture model is used after the software architecture has been defined. Kokomo 2 is a comprehensive system that is detailed in the textbook. The Delphi estimation method involves forming a group of experts or experienced developers. The system and its major components are described to the group. Each expert independently estimates the effort. Each expert presents the estimate and rationale behind the estimate. The last 2 steps are repeated until a consensus estimate is reached. Agile estimates are expected to change as reality changes. The estimate takes into account the current knowledge and uses intuition and common sense. Planning poker is a modified Delphi approach. The following steps demonstrate an agile approach to effort estimation called planning poker. Each participant is given a deck of cards containing the Fibonacci sequence numbers or any agreed upon numbers and reminded that good enough is good enough. The moderator reads a description of the story point and the product owner answers questions. The participants perform the following. Each participant presenting their estimates and participants show their estimates simultaneously. Participants with the highest and lowest estimates are asked on the rest now. Participants repeat the last 2 steps until a consensus estimate is obtained.
You can't expect your team to manage one with this. With Monday.com's flexible management system, however, you can...
Wait. Okay. Can we have again nanti dalam 3 for 10? Boleh? Putus-putus. Now can you hear me? We're gonna have 15 minutes break. 15 menit we come back again 5 before 10, 5 minutes before 10. Okay. Okay, siapa belum siapa belum ambil QR code? Boleh ambil QR code. Ada lagi? Ada siapa-siapa nak ambil attend manual? Okay. Matrix number. Siapa yang nak manual attendance bagi matrix number? 13. 60. Enam 4. 91. Okay. Lagi ada lagi. Anybody? One manual attendance can give your matrix number on the chat. Okay. So saya boleh key in. Semua? Ada. Okay. So okay. So we finished with the first part, which is the software cost estimation and so on, and the project plan, project management plan. So next one, we're gonna go to management. Okay, so we look at the risk management continuation from the previous one. Okay, boleh dengar? Boleh dengar? Okay. Okay. Okay, so we continue with the risk management. So what can possibly go wrong when you do your project? Okay. So we look, consider as a college student or as a university student, this is the thing that is the risk that you might encounter as a student. Okay, computer related, lost file, lost flash drive, lost hard drive, damage, and so on, crash computer, corrupted. This one is some of the regular excuse or regular problem, regularly risk the student face when you are as a university student lah. Maybe ada sekali dalam you punya tu adalah hilang file ke flash drive ke apa tu. Okay, and in terms of attendance and time management, and then late for class, late for submission, homework and so on. Okay, late or miss. And also, for average project, so the average project, the risk or the thing that can go wrong is testing that takes longer than planned. Some bugs you cannot resolve, you take forever to solve one bug, for example. Vendor cannot deliver a product on schedule. Okay, so for example, in terms of vendor, you ask them to deliver a computer, for example. For example, your project involve the system and the hardware, and the vendor cannot deliver your hardware on time, for example. That is the thing that can go wrong in your project. Okay. And for example, the critical engineer or someone who have the knowledge, control the knowledge promoter just now has an accident or become a parent. So when someone, the critical engineer, someone become a parent for the first time, for example, he will take a lot of like not enough sleep and so on. So it will affect his for the first few weeks, for example, it might affect his work. Okay, or has a major surgery. Critical engineer leaves a project or company. Oh, this is a big problem. And change of ownership or project on hold, for example, the client for example, the client company changed the ownership and the client said, oh, I don't want this project too much money, for example. And also, there's a major downsizing in your company, for example. So you might lose a few people in your team. Okay. And then you also have the dysfunctional staff in your team, for example. So this is all the things that can make your system delay. Okay, flood or power failure. Okay. So we look at the definition of risk. Risk is the probability of incurring some net loss while pursuing a goal. Okay. Okay. So pursuing a positive risk usually called an opportunity. Okay. So risk can be about positive risk or negative risk. Okay. And also such as financial investment may result in either a net gain or loss. Okay. So reducible risk is one which is predictable or within our control. You know there's a risk, but you are ready for it. Okay. And we can reduce the likelihood of loss by taking steps to mitigate the or avoid the risk. Okay. Irreducible risks are more difficult to deal with. This may be unpredictable. Okay. We know the risk can occur but have no basis upon which to estimate their probability of occurrence. For example, loss of the key project resource. Okay. For example, your engineer just now, or your main programmer, for example. Beyond our control, the risk is maybe unprecedented and or exceptionally unpredictable. For example, there is a war, natural event, a flood, and so on. So this type of risks are handled through business continuity practice. Okay. Risk management. This one is definition of risk. So risk management is the approach or systematic approach to reduce the harm due to the risk. Okay, making the project less vulnerable to challenge or failure. For example, the cost or schedule overrun, scope decrease, quality reduction, and this resulting product product more robust. Okay, so this is the element in risk management. You analyze the risk, and you also control the risk. Okay, when you identify the risk, you know what's the risk have. You give the identification of the risk, you assess the risk, and you give priority to the risk. Which one is more important? Which one is the bigger problem if you have if the risk occur? Okay, and then you can need to come up with the risk control. How you control if the risk actually happens. Okay, so risk management planning, risk resolution, and risk monitoring. Okay, so this is the element. How you categorize risk. My thread hilang lagi. If my line is not good, cepat-cepat komen lah. Otherwise, I can't see the tanda terus hilang macam tu. How to categorize risk? It's three category: known, unknown, unknownable. Okay. So the known risk is that one that can be uncovered after careful evaluation of the project plan, business, and technical problem, environment, and other reliable sources of information. For example, the unrealistic delivery date, lack of user input, and so on. That is the known that you can you can cover or identify the risk from all the previous project or so on. Okay, refer to those risks that can be estimated from historical information. Okay, so from your previous project or so, with the client or from a similar project. Maybe you said you can deliver in 3 months, but then you can be delayed like to up to 6 months based on the previous one. Can be mitigated by management techniques and through response plan should they occur. So example is potential delay in delivery from third-party vendor, especially if, for example, the client specifically asks you to deliver something to be included in the project, for example, the hardware or maybe the software. So if you need to buy that thing from other vendor, that then the risk is if they're delayed in delivering. Okay. And so the key personal leave project and development system down, for example. Okay, so that is the risk that can occur as a non-risk. Predictable risk, but unknown risk. You can predict, but you don't know risk that can be extrapolated from past projects. For example, staff turnover, your poor communication with the customer. Refer to those risks that we know have the probability of occurring, but do not know the precise impact of it. Okay, cannot be managed directly, but can be mitigated by the use of contingency plan. Example, loss of key personnel due to turnover, for example. Okay, that is the predictable. Unpredictable risks are risks that are hard to predict. Unknowable risks, one of it is that refer to those risks that are outside the scope of historical or probability models of the project, beyond the scope of risk management, and usually are addressed by the crisis or disaster management in your company. For example, is corporate failure. It can be your side of corporate or your company, or it can be the client side of corporate. Natural disaster, for example, flooding. Usually in Malaysia, we have flooding. Okay, act of terrorism or war, major snowstorm. This one is UK or overseas punya lah. And power loss, yeah. Okay, so that is the unknownable risk. You don't know what is going to happen. Okay, risk management model. This one is if you look at it, it's interconnected with each other. So if the process or the task that is in the model is risk management planning, risk identification, quality risk analysis, tracking, auditing of the risk history, evaluate and revise, quantitative risk analysis, risk control, risk monitoring, and risk response planning. Okay, so it's interrelated with each other. For risk management planning, you already looked at the risk management, what's risk, what is risk management. Now we look at risk management planning. So this is the how you manage, how you plan to manage the risk. Okay, so you address how to approach, plan, and execute all the project of the project risk management. The risk management plan is critical to overall risk project management process. A well-defined comprehensive risk management plan enhance the chances of success of the risk management plan. Okay, so you need to have a very good risk management planning. First, you need to address identification input, enterprise environment factor, concern with aspect of the enterprise outside the project. One source may be enterprise historical information, and industry or academic research is another excellent source for you to identify the risk. Okay. The environment, enterprise environment factor again, most critical environment factor are the risk tolerance level of the organization and the stakeholders. So risk tolerance express an inherent trade-off decision between benefits and costs. So stakeholder will take a risk if the benefit to be gained outweighs what could be lost. Okay, so this is the enterprise environment factors. Conversely, stakeholder will avoid taking a risk because the cost or impact is too great for the amount of benefit that can be derived. Okay. Okay. So the risk tolerance level is the one. Okay. Organization process asset, input to risk management. This one is the thing that you need to include in your risk planning. Organization may already have policies and guidelines that define its risk tolerance. Okay. So you need to look into that. If they already have the guidelines, so you need to look into the documentation or look into the guideline and include it in your planning. Projects and statement, this one where you need to collect or you need to do the project assumption, constraint, and initial defined risk in scope statement. The scope project scope statement contains several information source of risk management. So project deliverables, project constraint, assumption, initial organization, initial defined risk, and schedule milestone. This is the thing. This is all the information that you can look into it and identify the risk. Okay. Risk management plan. Risk categories are primary source of input. Budget and schedule for risk management activities. So if you look at this one, everything at your report or everything at your asset SPMP just now, we can look into it and try to identify the risk associated with each process, with each item, and so on. Okay. Project management plan. Project management plan contain schedule, budget, and quality plan, which may be a source of risk. Also becomes an integral part of the project management plan. All other project management process and guidelines comprising the project management be considered in light of potential risk. So you need to look at all the document and you need to try to identify the risk from that document. Risk management should be consistent with overall direction and management approach of the project. Okay. Tools that you can use to manage the risk management, to do the risk management planning. You need risk management planning tools. You can have a meeting. Okay, planning meetings are the main tool of risk management. Okay, so all the attendees should include the project managers, members of the project, members of the project, stakeholders, management team, who can contribute to the risk related information. Okay, so each person need to look at the risk, need to identify the risk that is related to them that they can see. Okay, because sometimes the project management team did not know the risk from the project manager side, for example. So the attendees need to identify all the risks related to them. Meeting will involve analyzing the risk of the project, risk tolerance of the organization, and collaborating risk with the project and organization. Okay. So the output of that is the risk management plan. Is all the output from the risk management planning process. Risk management plan is detailed. Okay. So methodologies, how risk management will be performed, including method, tools, and sources of data. For example, how for if one of the key programmer quit, for example. So how you gonna handle that risk? Okay. Roles and responsibility, team of people responsible for managing identified risk and response, the risk owner. So for example, just now Terus sekejap ah. Okay. Sambung lagi. Okay, already. Okay, if you look at the risk category, starting point for risk category, they have 4: technical quality performance and risk, project management risk, organizational risk, and external risk. For technical quality, unproven and complex technology, the use of technologies that is, for example, your client asks you to use the technology that is not never been used by other company before, and it's not proven whether it's work or not. So that is the technical risk. Changes of technology, unrealistic quality, unrealistic performance goal. This one usually from clients. Okay, usually a client asks you to do something, and sometimes the quality and performance goal that asked you to do is unrealistic. Okay, so that is in terms of technical performance risk. Project management risk, improper schedule and resource planning. Okay, so for example, improper schedule is it's supposed to be, for example, you can finish the work in 2 years, for example, or 1 year, but you in scheduling you said you can finish in 6 months. So that is the improper scheduling. Okay, poor project planning, improper or poor project management, discipline and methodologies. Okay, so that is from the management, from the management part. Okay, the risk from the management part. Organizational risk usually involve with human resource conflict due to multiple projects occurring at the same time in the organization. So this one, for example, you have few projects, and one person is assigned as a programmer for a few projects. So there will be a resource conflict. Which one you want him to do at one time? Okay, and realistic scope, time, and cost objective with respect to organizational resources or structure. Lack of funding for the project or diversion of funds from the project to other projects. So for example, at the beginning, this one is for the client side, for example. They have a budget to do the like in the beginning of the year, 20,000. In the middle of the year, they need the money to do something else, so they cut the budget and give that 10,000 to the project, for example. So that is when the funding for the project is divert to the other project. Okay. Management oversight changes, loss of project champion. Okay. Usually, for each project, you have a project champion who knows most of the thing about the project. For example, it can be a team leader, it can be the project manager. Okay. So if you lost the project manager, then you lost the person that knows almost everything about the system. So it will give a lot of setback to your project. And also there's a project politics. Everywhere have politics lah. Okay. The external risk can be the new laws or regulation. It can be from the government. It can be from the organizational itself. Okay, labor issue, weather. For example, it can be the flood will damage. For example, the flood damage um, your computer and so on. So that is the external risk. Changes in ownership. It can be your own company or the client company. Changes in foreign policy for project performed in or part of in the other country. Foreign policy. This one, if for example you do a system or project for an Australian company, for example. So when there is a foreign policy changing, it might affect your project. Okay. Catastrophic risks are outside the scope of risk management planning, require disaster recovery techniques. For this one is for the bigger risk lah, earthquake, meteorite, volcano, hurricane, and so on. Okay. Let's break down. Risk categories can be represented visually in risk breakdown structure. Diagram provides hierarchical decomposition of risk categories. So you look at a project, it can have the technical, it can have the project management, organization, and organizational and external. So This one is an unproven technology, technology changes, complex technology quality and performance, schedule planning, resource planning, project discipline, cost estimation, and budgeting for piece that is under project management. Risk under organizational is the project schedule, not realistic, unrealistic objective, for example, like a funding and the management itself. And for the external risks, laws and regulation change, weather, labor issues, and catastrophic risk. Okay, so this is the project risk breakdown structure. To identify a risk, you need is a process of concern with determining what risk might have an impact on the project. So you need to identify. Okay. In addition, risk identification seeks up to profile risk so that effective mitigation and response planning might be possible. So you need to identify. You need to look at the risk and so that you can plan on how to face or how to solve the risk if it's occurred during your project. Okay, so risk identification is an iterative and incremental process that continually adds new risk, deletes non-risk, and refine existing risk profile as a project progress. Okay, so risk identification is not a one-time process; it's a continuous process. Okay, so that where risks are found, it can be in the budget, it can be on the schedule, scope and requirement changes in the project plan, management process, technical issue, personal issues, hardware, contracts, political concern, business risk, legal risk, and environmental risk. Okay, so three types of software risk. Written a project plan. For example, if the risk materialize or if the risk happen, then it is likely that the project schedule will slip and cost will increase. Okay. Okay. So the type of risk that is threatened that will threaten the project is in budget, scheduling, personnel issues, resource, project plan, customer, project management process, requirement problems, project complexity, and hardware and environmental risk. Okay, so that is the type of risk that will threaten the project. Technical risk is threaten the quality and timelines of the software to be produced. Okay, the design, implementation, interfacing, verification, cutover, maintenance, and security. This is where the technical you can find the technical risk. Okay, business risk threaten the viability of the product we build, building a great product that no one wants anymore. This one is the market risk, building a product that no longer fits into the overall business strategy for the company. Okay, so maybe the company changed the strategy, and the thing that you do now is not needed anymore. For example, building a product that the sales force doesn't understand how to sell. Okay, this one you make a product, but your sales personnel in your company don't know how to sell or what it's for example. Okay, losing of support of senior management due to the change in the focus and change in people. That one is management risk. Losing budgetary or personal commitment, budget risk, contracts, personal concern, and legal risk. Okay, so this is all the risk. The tools that you can use to identify the risk, documentation review. So you can review all the documentation that you have, effectively a thorough review of all the inputs to the risk identification process. So for example, you have the project planning and so on, the budget and so on, and your agreement and so on. So that is the thing, that is the document that you can review to identify the risk. Okay. Information gathering techniques. This one is you have a meeting, you have a brainstorming, and the Delphi techniques. Okay, so the brainstorming with right participation and proper facilitation. Brainstorming is a self-generating generating process, so you can identify the risk during that meeting. Delphi technique employs a facilitator who distributes a questionnaire to participants and who compiles and synthesizes the result. Participants do not interact directly as they do in the brainstorming. Okay, so that is the information gathering techniques, the way you identify your risk. Third one is by using interviews. Use standard question and answer technique with various stakeholders or anyone with project-related knowledge. Okay. Root cause analysis. This technique helps determine the source of the risk. Involve deep analysis of identified risk in order to root out other potential risks. Okay, so you look at the root cause analysis. You look at you see the risk. What is the root cause? So if you can eliminate the root cause of the risk, then you can root out other potential risks also. Okay, so the source of risk may seem superficial and directly visible, simply the most immediate source. Okay. However, often the true source of risk, its root cause is less obvious and not easily detectable. Hall suggests using the five whys approach. Ask the question why 5 or more less time to each risk. So each successive question move closer to the root cause. Not a highly robust method, but simple and effective. Okay. Checklist analysis based on the historical information and previous project team experience. Carry one or more similar project. Risk can be compiled into checklists. Okay, lowest level of risk apa tadi can be used in starting point for checklist. Yeah, RBS. If you look back at RBS, this one, risk breakdown structure. So that this table just now you break it down. Okay. Can be used as starting point for checklist. Checklist of a project cannot be exhaustive. We need to remember each project is unique. Okay. Assumption analysis validates the assumption identified and documented throughout the project planning process. Assumptions should be accurate, complete, and consistent. Assumptions are tested against two factors: strength and validity of the assumption, and consequences to the project if assumptions are all to be false. Okay, there are things that you need to assume, because if you cannot get the fact or the correct information about the project, you need to make an assumption, but you need to document the assumption. Okay. False assumptions should be reclassified as risk. And you also have the tools to identify the risk using the diagramming techniques, cause and effect using the fishbone or Ishikawa diagrams, system or process flowchart, and influence diagram. Okay. For the cause and effect diagram, also known as Ishikawa or fishbone diagram, show the relationship between the effect of problems and their causes. Depict the potential cause and sub-cause of the problem and the effect that each proposed solution will have on the problem. Useful as a tool to visually presenting and capturing cause and effect relationship. So this is the example of the fishbone diagram. Okay. Action meeting, preparation, moderator, familiar with the process. This one is the planning. Okay, determine participants and so on. And this is the process from beginning to the end. Effective inspection. Okay. Inspection meeting. So this one is the fishbone diagram. Okay. This one is the cause and cause and effect diagram for this part is the cause. Okay. This one is the effect. Module defects. So if the process requirement design, environment, staff, and testing, the cause maybe something happened here. If the process requirements is wrong, for example, this will cause the module defect. Okay, so this is you need to identify. Okay, this is the cause and effect diagram. So if the risk happen, for example, during the design, for example, so it will make your defect, your module have errors. Okay. System and process flowchart. This one is the flowchart. Familiar diagram to most stakeholders. Show logical step needed to complete the objective. Show how elements of the process or system relate to each other. Depict cause and response relationship. So risk owner notifies PM project manager of the event or risk trigger. Risk response plan executed? If yes, respond plan review of effectiveness and so on. So this is the flow chart that can be used, can be followed every time you face a risk. Okay, this is the process, okay, that you can follow. And you need to ask question: high risk score? If no, assign resources, implement response plan. If yes, review risk and risk response plan. Okay, and monitor response, plan execution, document result. Okay, so this is the preparation symbol. The one is the square one is the process symbol. The round one is the termination. This one is middle for the flowchart symbol. Okay. Influence diagram primarily used to show the causal influence among project variables. May also show the sequencing of event used to visually depict risk or decision, uncertainties or impacts, and how they influence each other. Okay, so you can if you look at this, it's the quality, it involves the cost, the time, and the scope. Okay, the techniques for you to identify the risk based on the past experience is one way. Okay, based on your experience or based on historical data, perhaps through the use of project database. Okay, so you look at the data that is already in the database. The risk example from the database, you can see sometimes the user enter the data not wrongly, for example. Okay, and if the data is not correct and the system gonna give the wrong output, for example. So that is one of some of the technical risk. Okay. Decision driver analysis, where the key decision are examined for risk, the factors influencing decision of possible sources of risk. So threat identification and security risk. If you have, for example, you have a network system or online system, so you need to look at the risk that can occur if it is open to online. Okay, so the threat identification. Risk item checklist. Checklist is useful for supporting risk identification of unknown and predictable risks in the following subcategories. Okay, so the product size, risk associated with overall size of the software to be built or modified. Business impact, risk associated with constraint imposed by management or by the marketplace. Customer characteristic, risk associated with the sophistication of the customer and the developer's ability to communicate with the customer in a timely manner. Process definition, risk associated with the degree to which the software process has been defined and is followed by the development organization. Okay. The development environment, risk accessibility and quality of the tools to be used to build the product. Technology to be built, risk assessment the complexity of the system to be built and the newness of the technology that is packaged by the system. Okay, staff size and experience. This one is involved humans, risk assessment with overall technical and project experience of the software engineers who will do the work. Okay, so this is the checklist that you can have in your risk. Okay, so you can have 2, 4, 6, 7. Okay, 7 checklist. So you check product size, what are the product size for your system, and so on. Okay. The paradigm for risk management. If you have a risk, so there is a iteration or a continuous process for the risk management. So you identify, you analyze, you plan, then you track the risk and you control it, and then you will do it yourself again. Okay, you keep on doing this to identify the risk in the system. Okay, in the project. How risk averse are you? So risk averse people don't possible and prefer to work efficiently. more service-oriented than self-oriented, value institution and observe tradition. This risk averse people. Risk-seeking people who like to look for risk is the like action and act impulsively at times, seek excitement for the thrill of experience, resourceful and prefer not to plan or prepare. I'm more self-oriented than service-oriented. I like to answer another person position. So dia suka cari masalah dan dia risk seeking. Risk neutral people. I trust my intuition and I'm comfortable and unknown. I think about the future and have a long range objective. Natural curious and often ask why. Enjoy generating new ideas and work best when I'm inspired. Is the risk neutral people. Okay. For risk management, assess the risk. So the objective, you look at analyze the risk in a cost-efficient manner. Determine source of risk, determine risk exposure, determine time frame for action, and determine the highest severity risk. Okay, that is you assess the risk. They have two types of risk management: reactive risk management and proactive. So for reactive risk management, project team reacts to risks when they occur. Mitigation plan for additional resource in anticipation of firefighting. Failure, fix the on failure. Resources are found and applied when the risk strikes. Crisis management, failure does not respond to applied resource and project is in the so that is the reactive risk management. For proactive risk management, formal risk analysis is performed. Organization correct the root cause of the risk by examining the resources and lie beyond the bounds of the software and developing the skills to manage the change. Okay. You need to also prioritize the risk. One way to prioritize risk is to estimate the probability of its occurrence and its consequences when it occurs, the loss that you will face if it occurs. The expected value of the loss for the risk can be used for prioritization. This expected value is called risk exposure. Okay, there's a way for you to do the calculation. I will not cover it. Okay, risk agency assessment. Do not try to deal with all risks at the same time. Okay, so you need to identify what is more urgent, which is not urgent. Analogous to rolling wave planning, determine how soon potential risks might occur. Develop risk response plan for those risks that might occur soon. Okay, so if you know that it will occur, so you do the contingency plan. Okay, for greater efficiency and effectiveness, only the top 10 risks should be actively managed. Maintain a watch list of the remaining risks to replace those on the top 10. Lists that are mitigated, controlled, eliminated, and that not or don't materialize. Okay, so you assess the urgency of the risk and you identify the top 10 which need to be managed. Okay, risk response planning. Risk response planning is concerned with developing options and possible reactions to mitigate threats and exploit opportunities discovered during the risk analysis process. So the severity of the risk dictates the level of risk response planning that should be performed. Risk with low severity is not worth the time it takes to develop detailed risk response. Okay, so don't waste your time on the low severity one. Risk response should be cost effective. If the response cost is more than the cost of the risk, probably a less costly risk response. Okay. Risk response must be timely. Risk response itself become a risk. Okay, and an untimely risk response itself become a risk. Okay, so you must be on time when you take action against a risk. Risk response must be agreed by all the project agreed to by all the project stakeholders. Risk response must be assigned to an individual or the risk owner who is responsible for monitoring the risk and executing the risk response plan if needed. Okay. Strategies for negative risk or threats. Like I said just now, there is a positive threat, positive risk and negative risk. For negative risk, you can use the avoidance strategy for you to face the negative risk using avoidance. Okay, risk avoidance evades the risk, eliminate the cause of the risk event, or change the project plan to protect the project objective from risk event. Okay, risk avoidance eradicates the risk by removing the risk cause. Risk avoidance is more suitable for the early stage of the project to improve communication, additional resource, and more clearly defined scope. Example is the risk of interfacing membership management system. Two external user membership system can be avoided by eliminating requirements to do so. Okay, so if you if you're creating the system and you want it to be communicating with other, you have the interface with other system that is already available outside. So if you don't you identify the risk that the system that you're developing might not be able to be connected to that system. So what you need to do is you just say to the client, we cannot do this one. So you just eliminate, or you just don't do that type of that connecting that requirements, for example. So that is you eliminating the risk of interface system, okay, problem, interfacing problem. Okay, risk transfer, this one is avoidance, you avoid the risk. You transfer, move the risk and the consequences of that risk to a third party. Responsibility for the management of that risk now rests with another party. It's not your risk anymore. Risk transfer comes in many forms, but it's most effective for financial risk. Example, insurance is one form of risk transfer. Okay, so you use insurance, meaning that the risk transfer is if you don't have insurance, you are the one who is responsible for that risk. The same with the car, for example. You have a car, if you don't have insurance, the risk is yours. Anything happen to the car, it's your responsibility. But because you have insurance on the car, if anything happen to the car, then you can claim it to the insurance. So you transfer the risk to the insurance company. It's not on you. Okay. The third one is contracting. Contracting is another form of risk transfer. The contractor accepts certain aspect of the risk as possible for the cost of failure. For example, the fixed price contract, contractor increase cost of the contract to compensate for the level of risk they are accepting. Okay, and also cost reimbursable contract. Contractor receive compensation for additional cost. Majority of the risk remain with the buyer. Risk mitigation, monitoring, and management. Mitigation is how can we avoid the risk. Monitoring is what factor can we track that will enable us to determine if the risk is becoming more or less likely. The management risk is the what contingency plan do we have if the risk become reality. Okay. If you look at it in detail for mitigation, risk mitigation attempts to reduce the probability of the risk event or its impact to an acceptable level. Mitigation takes the viewpoint that fix a problem earlier and the project is less costly than fixing it later. So for example, performing more tests using simpler process, perform simulation, choose vendors for reliability over cost. Okay, so that is the mitigation process. Risk acceptance, the risk is acknowledged but no action is taken unless the risk occurs. Appropriate when it is not possible, of course, effective to address the specific risk in another way. Passive acceptance is the simply documents that the acceptance strategy has been adopted and leaves the project team to deal with the risk. Active acceptance establish risk reserve, such as a pool of fund, time, or resources to be held for use in response to the risk event. Okay, it's happened. Okay, so that is the risk acceptance. Contingency plan involve planning alternative to deal with the risk that occur. Do not seek to reduce the probability or impact of the risk. The strategy accept that the risk may occur and plans way to respond to the risk. Okay. Plan is executed when the risk event occurs. Contingency plan must be placed well before the time the risk may occur. Okay, so you need to plan. The risk contingency plan is the one that you already have, or you already have the knowledge and you already have the plan. If this thing happen, we're gonna do this. That's your contingency plan. Contingency or fallback plans are developed for risks with very high impact or with response strategies that may themselves be risky. Contingency plan usually detail a significant alternative to pass through part of the project. So, for example, is disaster recovery plan. Okay, example, if you expected uh, uh, every year they have budget during the same time, for example. So, what you're gonna do if you have that happen? Okay, so you need to have contingency plan. Tools for contingency plan, contingency allowance or reserve, provide pool of funds, time, or resource that are held or used in response to the unavoidable risk event. Example is include the contingency time in case of loss of key personnel or your one of the team member quit the job, for example. Okay, fallback plans or plan B. Plans are developed for risks with high impact for the risk strategies that may themselves be risky. Address fallback plans may be used to address secondary risk. Example, use a relational database plus object-oriented interface in place of the pure OO database. Okay, so that is the fallback plan. Strategies for positive risk or opportunities. Like I said just now, there's two types of risk. It's a negative risk and also a positive risk. So positive risk is usually an opportunities. You can exploit the opportunities. Exploitation involves looking for opportunities for positive impact. Example, reduce project duration by using more experienced resources on critical tasks. Okay, or sharing the positive envelope to transferring. Sharing assign risk to a third party owner if who is better able to use the opportunity if there is present. Example, form a joint venture between a technical company, software company, and marketing and sales firm. Example, if you don't have the knowledge on the marketing, for example, so you join venture with the marketing so that you will understand more of the system and reduce the risk. Okay. Monitoring risk must be managed. Risk must also be one of the principal concerns in the project management team. Okay, so risk must be reported. Any risk that you think gonna happen or things that is already happened, you need to report it to the management during the meeting. Risk should be an agenda item in the weekly team meetings. Should be included in the project status report. Weekly project review should be reviewed all risks. Okay, so in the team meeting, you should briefly review all outstanding risks, the one that you haven't solved. Should estimate whether each risk probability has increased, has decreased, or it's still the same. Risk owner should report on their assigned risk. Okay, so this one is done during the team meeting. In the project status report, list all risks for which the degree of risk has changed. Okay, so in your report also you need to include the risk. Weekly project review all risks, even those that have been eliminated. You need to review it again. It might occur. You can learn from it so that it will not occur in another part of your system. Goal is to uncover new risks or identify those that have been reincarnated. Okay, reviewing risks in weekly team meetings keep the team and risk owner aware and sensitized to risk. Okay, so it's always aware and by talking about it every week, then we can always put it in our mind. So once it want to happen or already happened, you can identify it. Including risk in the project status report prepares management for the times when risk happen. Okay. So the 7 principles looking this one is to avoid risk lah. Okay, maintain global perspective, view software risk within the context of system and the business problem, take a forward-looking views, think about the risks that may arise in future, establish contingency plan, encourage open communication, integrate, okay, emphasize in a continuous process, develop a shared product vision, encourage teamwork. Okay, so that is the 7 principle that you can give. Okay, so that is the end of the first part for today. Um, so this one, so I already covered this part is on the first part of it just now. It's in the project management, software project management. Okay, so from what we already covered is on the team formation, team analysis, team conflict, and so on just now in the lecture this morning. And this one is on risk management. Okay, we also look at the cost effort estimation. So we start again. We take a rest again. I need to raise my voice. Sudah lain, sudah bunyi suara saya. We have, can we take like another 15 minutes before I continue to the next slide? Boleh? 15 minutes again, huh? Any question? You have any question? Question or not? Ada soalan, boleh faham? Tak ada exam kan, fahamkan sajalah. How's everyone? Tawa kau kali Risa.
Good, good.
Semua dah nak habis dah kan? Everyone is final semester, right?
Yes.
Ya, dah ada yang dapat kerja dah.
Zairin, madam, Zairin.
Serin dah dapat kerja. Hopefully semua nanti dapat kerja lah. Now a bit slow kan dengan pandemic. So hopefully after vaccine it will slowly open. Everyone now is going to IT juga. Without IT you cannot really survive during the pandemic. Duduk rumah tengok komputer pun sahaja. Okay, so hopefully everyone will get a job in the near future lah. Okay, rest kejap. 15 minutes. Become 15-20 pun boleh lah. By 11 15. Okay, 11:15 back. At 11:15. Okay. Okay, so boleh pergi makan dulu ke apa ke? Boleh makan ke pun. Okay, see you later. Oke, sambung balik. Dah makan ke semua? Tahu, ada orang kah? Ah, 125, supposed to be 140 rasanya. Satu, Oke, nanti pukul 1 kita ambil gambar. So, siapa yang tu standby ya, pakai tudung, pakai baju elok-elok. By 1 o'clock nanti kita ambil gambar. Okay? So, nanti kena on kamera sekejap. Okay, participant 98 dalam ni. So, kan. Okay, boleh dengar? Sekejap. Saya buat sekejap boleh. So, in the next 3 hours, you need to finish this one. Verification and validation. Sekejap, kenalan. Okay. Boleh tengok ah? Boleh tengok, boleh dengar?
Boleh, madam.
Okay. So we just continue with verification and validation. So dalam part verification validation ni, this is the some topic that kita akan cover lah. Okay. It's not following the exact yang ada dekat sini lah. It's tapi we cover most of it lah. Okay. Dalam lecture tu. Okay. So the lecture is long because I supposed to do it in 3 hours. So if you look at the slide, it's 147. Hopefully I can finish one by dekat-dekat before tu lah. Okay. Okay. So verification, validation concept, inspection, reviews, audits, testing types, testing fundamental, unit testing, validation, test plan. This one you already do actually in your FYP. Okay. Defect tracking, limitation of testing on a particular domain such as this one nanti kita akan discuss. You look at the video lah, ada video nanti dari ada saya jumpa dekat internet on that topic. Okay. So the most common software problems is incorrect calculation. This one is the basic yang you buat masa kita mula-mula buat. Sometimes we do the even calculator, sometimes we miss the point or the comma or the symbol, so dia akan jadi incorrect calculation. Incorrect data edits and ineffective data edits, incorrect matching and merging of data searches that yields incorrect result, incorrect processing of data relationship, incorrect coding, implementation of business rules, inadequate software performance, confusing and misleading data, software usability by end user, obsolete software, inconsistent processing, unreliable result of performance, inadequate support of business needs, incorrect and adequate interface with other system, inadequate performance and security controls, and incorrect file handling. This is some of the common software problem. Okay, so this is the history why why they call it computer bug. Okay, in 1947, Harvard University operating a room-sized computer called the Mark II. Chemical relays, glowing vacuum tubes is all in that room. Technical programs the computer by reconfiguring it. Technician program the computer by reconfiguring it. Technician had to change the occasional vacuum tube. So a moth fly into the computer and is zapped by the high voltage when it landed on the relay. Hence the first computer bug. Okay, so if you look, this one is the room, and I think this one is the first bug. Okay, you can see at the picture. So the bugs that you usually call it is the defect, the fault, problem, error, incident, anomaly, variance, feature, product incident, product anomaly, inconsistency, and failure. This is all we call bug sometimes. Okay. So defective software is when we develop programs that contain defect. What kind of defect? How many defects in the program? Okay, it's hard to predict the future, but everyone might have this type of in the future lah. You might do it, but so it is highly likely, but that the software we develop in the future will not be significantly better from the software nowadays lah. Okay. So again, we look at if you look at the risk management just now, the sources of problems. You can look into the requirement requirement definition. Okay, so the requirement analysis is where you look at the system requirements. So what's the thing that is needed in the system. So it can cause a problem to the system if you have erroneous in predicting or in getting the information from the user. Incomplete information and inconsistent requirements from the user will contribute to the defect of the system. Okay. During the fundamental design flow in the software, during implementation, mistake in chip fabrication, for example, wiring, programming fault on this code, and during the support system for programming language, faulty compliers and debuggers, misleading development tools, for example. This is all the source of problems in your system. Okay. Also, if you don't have enough testing, okay, incomplete testing for verification, mistake and debugging, and the evolution also sloppy redevelopment or maintenance, introducing of new flows in attempt to fix the old flows, incremental escalating or inordinate complexity of the system. This is all the source of problems. Okay. So also the adverse effect of faulty software in communication, loss or corruption of communication media, non-delivery of data. This one is the faulty inside the system itself, space applications, loss of life, launch delay, and so on. Okay, defense and warfare. If you have the faulty system in defense, it might lead to misidentification of friend or foe. Okay. In transportation, if you have a faulty system, you see what happened that day when the train yang dekat mana yang berlanggar itu. So that is the transportation effect of faulty software lah. It's you can say it's because of the software, because they don't identify that those two trains are on the same track. Okay, can lead to death, delay, sudden acceleration, ability to brake, and so on. Safety critical application. It can lead to death or injuries. Electric power, also death, injuries, power outage, long-term health hazard, and so on. Okay. In money management, for example, if you have a system or you make a system that manage the bank and you have something wrong with it, fraud, violation of privacy, shutdown of stock exchange of banks, negative interest rates, control of election, wrong result intentional or not intentional. This one is the effect of the faulty software lah. Okay, control of jails, for example, if because some of the jail they have the software or to control the opening and closing the door. So if you use the technology added escape attempts and success, accidental release of inmates and so on, failures in software control lock. Okay, and law enforcement is false arrest and imprisonment. Okay, so if you have the faulty software, this is the effect that it can cause people. Okay. So this is all the example of bugs or example of faulty or an error happen in the code. I have a few here. Bug in the space code project Mercury Fortran code had the following fault. Okay, so do I from 1.10 instead of using comma. So because of this full stop and this comma, it's only happened once. If you do this one, it's do I 1 to 10. Okay, this one is what it meant. But the result, the fault was discovered in analysis of why the software did not seem to generate result that was sufficiently accurate. The erroneous 1.10 would cause the loop to be executed only once. Okay, so because of the dot, it only executed only once instead of 10 times. Okay, so that is the bug in the Fortran code project Mercury. Okay, in military aviation problem, and F-18 crashes because of a missing exception condition, if then and without the else clause. Okay, that was thought could not possibly arise. Okay, in simulation, an F-16 program bug caused by actual plane to flip over whenever it crossed the equator as a result of missing minus sign to indicate south latitude. Okay, so luckily this one is only the simulation, not the real flight. Okay, so so the tiny mistake just because of the minus sign then can make the plane to flip over. Okay. Year ambiguities. In 1992, Mary Banda received an invitation to attend a kindergarten in Winona, Minnesota, along with others born in 88. Mary was 104 years old at the time. Okay, because they put only the 88, but did not look at whether it's 90 or 2000. Okay, 2000. Oh no. Born in 88, not in 1998 or 1888. Okay, so he's 100 years old that time. Okay, because he's born 100 years before, but they thought he's only 4 years old. Okay, so because they didn't look at the numbers, well, previous two numbers, they only looked at the last two. So that's why Mary have got the invitation to attend kindergarten, even though he's 104 years old. Okay. Another one is Mr. Blooded Auto Insurance rate triple when he turned 101. He was the computer program's first driver over 100, and his age was interpreted as 1. Okay, there is a double blunder because the program definition of a teenager is someone under 20. Okay, in the system. So if first driver 100, you cannot drive if you're 1. Okay, so there is another error in the system. They did not first look at the system whether how old are you. Okay, because you still have license when you're 20. So this thing. Okay, and then dates time in integer, or this one cannot see. This one if you look, there is a 2,15 di atas ini. The number 32768 has caused all sorts of grief from the overflowing of 16-bit word. In Washington DC hospital computer collapse on September 1989, 215 12 days after January 1, 1900, causing a lengthy period of manual operation. Okay, because of the 16-bit word overflowing. COBOL used two character that field. Okay. The Linux term program which allows simultaneous multiple session over a single modem dial-up connection died worldwide on October 26, 19. The cause of the overflow is an invariable that should have been defined as unsigned int. Okay, because of the two characters. In the US, 5 nuclear power plants were shut down in 1979 because of the program fault in the simulation program used to design nuclear reactor to withstand an earthquake. The program fault was unfortunately discovered after the power plant were built. Okay. Okay, so they use the simulator. It looks okay, but then when they build it, then they realize there's something wrong with the simulation. Okay, so they have to shut down the power plant because they did not, meaning that they did not test it up to the standard of the by using the simulation. Okay. Apparently, the arithmetic sum, a set of numbers, was taken instead of the sum of absolute values. The 5 reactors will probably not have survived an earthquake that was as strong as the strongest earthquake ever recorded in that area. Okay, so that's why they have to shut down because it's a risky um, uh, reactor. Okay. Another error in Texas, 1896, a man received between 16,500 and 25,000 rads in less than 1 second over area of 1 cm. This one is the radiation therapy. He lost his left arm and died of complication 5 months later. In Texas, this all happens in 1986 when they produce the system. Sometimes make a wrong code in the system, so they give the patient like a lot of this radiotherapy. Okay. In Texas, man received at least 4,000 rads in a right temporal lobe on his brain. The patient eventually died as the result of the overdose. Okay. In Washington, 1987, the patient received 8,000 to 10,000 rads instead of the prescribed 86 rads. The patient died of complication of radiation overdose. Okay. So it's like how many times? 100 times. Okay. So that's why it can this one supposed to be medical to treat people, but it kill people because of the error in the code. Where when they put the doctor, when they put for example, this one I think is only like 40 rand they put, but because the system they multiplied it into 4,000, so it caused people to die. Okay. And then there is also a bug in AT&T is a company, telephone company in the US. In mid-December 1989, AT&T installed new software in 114 electronic switching system. On January 15, 1990, 5 million calls were blocked during a 9-hour period nationwide. Okay, because of the new software. The bug was traced to a C program that contained a break statement within a switch clause nested within a loop. Okay, the switch clause was part of the loop. Initially, the loop contained only if clauses with break statement to exit the loop. When the control logic became complicated, a switch clause was added to improve the readability of the code. Okay, so that's why the it makes the block call. Okay. Bank generosity, this one happened in Norway. A Norwegian bank ATM consistently dispersed 10 times the amount required. Many people joyously joined the queues as the word spread. Okay, so error in the ATM. A software flaw caused a UK bank to duplicate every transfer payment request for half an hour. So duplicate, the bank lost 2 billion British pounds. So if you withdraw withdraw $10, £10, they give you £20. Okay, the bank eventually recovered the fund but lost £500,000 of potential interest. Okay, this one is in India. An Australian man purchased 104,500 worth of Sri Lankan rupees. The next day, he sold the rupees to another bank for 440,258 rupees. the first bank software had displayed a bogus exchange rate in the rupee position. A judge ruled that the man had acted without intended fraud and could keep the extra 335 $750. Okay, so if we can detect the error in the system, then we can see. Okay, bug in Bonnie software. Bank of New York, BONY, had a 32 billion overdraft as a result of 16-bit integer counter that went unchecked. Bank of New York was unable to process the incoming credits from security transfer, while the New York Federal Reserve automatically debited Bank of New York cash account. Okay, so that's why it's have the overdraft. Bank of New York had to borrow 24 billion to cover itself for 1 day until the software was fixed, and that cost Bank of New York 5 million in interest payments. Okay, so you see, even though it's only 1 day. So okay, so that is all the error that you can see. There's other that while from my experience while I was in UK last time also, we see this type of bugs, especially in shop. Over here you seldom see the error in Shopee or anything, but in the UK we have a homepage where people will identify the error that happens in the online shop. So the one error that I still remember is the Tesco. They have a sale. Tesco change prices every Wednesday. Okay, so they have promotion. The promotion end on Wednesday, and they change prices. Most of the items. So every Wednesday, we're gonna some group of people that is in that website. They're gonna look is something wrong in the system. One time, what happened is in the gardening section in Tesco, they're supposed to do a 30% discount on their items. Supposed to, not 30, 10% kah? 10% discount. 10% discount on all of the gardening items because it's at the end of the summer, so the gardening items, they go on sale. So they're supposed to do the 10% discount, but what happened is they do the 10% price. So if the price of the item is £10, they're supposed to be £9 after the 10%. What happened is they changed it to £1. So everything is 90% discount rather than 10%. So some of the shop in the UK, they open 24 hours. So people go and buy a lot of things that night. And then the next morning, then Tesco realized that it's actually an error. So they changed the price back to 90%, 10% discount, not 90%. So that is the some of the experience that I saw, that when you do something with errors in the system, then but that one is not during the that one is not the um did not happen during verification and validation. It's more to the error by the salesperson that entering the, maybe he's not familiar with the system, so rather than putting the discount as 10%, he put the discount as 90%. So that is the, but that is the, in terms of computer errors that can happen. Okay, so so we continue with the objective of this testing, because in this topic we're going to look at the verification and validation. So why we do testing is so that we can execute the program with the intent of finding an error. Okay, to check if the system meets the requirement and be executed successfully in the intended environment, to check if the system is fit for purpose or not, and to check if the system does what it is expected to do. So this is why we do the testing. Before the testing is done throughout the process, and also before by the user. Okay, user acceptance. We can also have the test case. A good test case is the one that has the probability of finding as yet undiscovered error. A successful test is one that uncovers a yet undiscovered error. A good test is not redundant. A good test should be best of breed. A good test should neither be too simple nor too complex. Okay. What is the objective of software tester? So if you are assigned as a software tester, your your responsibility is to find bugs as early as possible and make sure they get fixed. Okay, and you need to understand the application well. Okay, study the functionality in details to find where the bugs are likely to occur, and to study the code to ensure that each and every line of code is tested. Okay, so it's also best to create a cases in such a way that testing is done to uncover the hidden bugs and also ensure that the software is usable and reliable. Okay. Then we look at verification and validation. Verification is typically involve previews and meetings to evaluate documents, plans, code requirements, and specification. It can be done with checklists, list issues, and issue lists, walkthrough, and inspection meetings. Okay, so verification is you verify what you are doing is correct. Okay, validation typically involve actual testing and takes place after verification are complete. So you need to first to verify everything is correct, and then validation is you validate it. So you use the test cases, you use the you do the testing to check it is valid, that the thing that you're doing is valid. Okay. Validation and verification process continue in a cycle until the software become defect free. Okay. So the testability, what are the things that you test? Operability, operation, observability, controllability, decomposability, stability, understandability. This is the thing that you test. Okay. So the process cycle, software development process cycle, plan, you do it, then you check, and then you action based on checking, and then you plan again. Okay, so this is the process cycle. Okay, sorry ada gangguan sekejap. Okay, so we just devise a plan. So you have the based on this one, the plan, the do, the check and action. Okay, check the. Okay, so plan a devise a plan, copy, define the objective and determine the strategy and supporting methods required to achieve the objective. And then you execute the plan, the do, create the condition and perform the necessary training to execute the plan. And then you do the checking, check the result, check to determine whether work is progressing according to the plan and whether the result is obtained. And then you do the action, which is take necessary and appropriate action if checkup reveals that the work is not being performed according to plan or not as anticipated. Okay, so that is the plan, do, check, and action. Okay. Cost of quality. Can look at the prevention cost, amount spent before the product is actually used or built. Okay. Cost incurred on establishing method and procedure, training workers, acquired tool, and planning for quality. That is the prevention cost. Appraisal cost is amount spent after the product is built but before it's shipped to the user. Cost of inspection, cost of testing, cost of previews. Okay, so this is the cost for you to make sure that the product that you produce is have a good quality. Okay. Failure cost, amount spent to report failure. Okay. So cost associated with defective products that haven't been delivered to the user or moved into production. Cost involve repairing product to make them fit as per requirement. So that is the failure cost. So meaning that if you didn't identify it early, it will cost you a lot. Okay. Next, we look at the software inspection. Before you do the testing, you need to inspect the software. People examine a source code presentation to discover anomalies or defects. Does not require system execution, so they may occur before implementation. This may be applied to any system representation. So it can be the document, it can be the model, it can be the test case, it can be the code if you already coded and so on. Okay, so this is the then the successful inspection is when a very effective technique for discovering defect. It is possible to discover several defects in a single inspection. In testing, one defect may in fact mask another. Okay, when you do the testing. So they reuse domain and programming knowledge, allowing reviewers to help authors avoid making common errors. Okay, so by reusing the domain or the programming knowledge that they have, they're using the code that they have usually. That helps them to reduce the error because the one that is already being success, they already used it before, it's less error than create from scratch. There are testing and inspection are complementary processes. Inspection can check conformance to specification, but not if customer real needs. Okay, because you just inspect, but you didn't check the testing. You do the testing of the system. You just look at the documentation and everything. Testing must be used to check compliance with non-functional system characteristics like performance, usability, and so on. Okay. Program inspection formalize the approach to document reviews. Focus is on defect detection, not defect correction. Okay, so you in inspection is you detect, you don't correct. Testing is where you do the correcting. Okay, defect uncovered may be logic errors, coding error, or non-compliance with development standard. Okay. Precondition before you do the inspection, a precise specification must be available. Okay, so that precise specification you can get it from the project management document where you have the detailed requirements. So the precise specification. Team members must be familiar with organization standards. Okay, all the presentation must be syntactically correct, no syntax error, or an error checklist must be prepared in advance. Okay, so you need to check each error. So you need to have the checklist. You have check this, you have check that, you have check that, and so on. Management must buy into the fact the inspection will increase the early development cost. Okay, so you need to tell the management that the inspection will increase the price at the beginning of it because you might change things, you might update things, you might do things at the beginning. Inspection cannot be used to evaluate staff performance. Yeah, you cannot base on inspection the staff using this error, so you cannot say that he's making this error, so reduce his gaji or whatever. Okay, cannot be used as to affect the staff performance. The procedure needs a system overview presented to the inspection team. Okay, and then code and associated document are distributed to team in advance. Error discovered during the inspection are recorded. Product verification are made to repair defects. Re-inspection may or may not be required. Okay, so if depends on the type of error that you defect that you recorded or that you see. So you can modify it or you not, but you already identified. Okay. Teams for project inspection are at least 4 teams members. Product author who write about the product, who knows about the product. Inspector looks for the error, omission, and inconsistency. Macam police lah, it's like police lah, inspector. Reader who reads the code to the team. Okay, so reader is who understand the code, so he can convey what the code doing to the team. Moderator is the chair meetings and record error uncovered. So he's the secretary lah who do all the recording. The checklist of common error should be used to drive the inspection. Okay, so if you have a checklist, you know what to look for, what error, what common errors they have, syntax error or sign error, negative, positive, and so on. Error language should be language dependent. So it depends on the language they're using. Okay. The weaker the type of checking in the language, the larger the checklist is likely to become. Okay. Inspection. Inspection fault classes. You need to have the classes of your data faults. For example, array boundary, control faults. For example, loop termination, input and output faults, all data read or not. Interface fault, parameter assignment, storage management fault, for example, the memory leaks and so on, and the exception management fault, all error condition track. Okay, so make sure that all the error is you have the output for each of the error. Okay, the rate for you to do inspection 500 statement per hour during overview. This one is just look through lah. For your overview is look through. 135 statement per hour during individual preparation. 90 to 125 statement per hour can be inspected by a team, including preparation time. Each 100 line of code costs 1 person day. Okay, so if a per 4-person team is used. Okay. Next one, we look at the software testing lifecycle phase. This one is the testing process. Okay, so we look at the requirement study, test case design and development, test execution, closure, and test process. So we look at the requirement study. Testing cycle start with the study of requirements, soft clients requirement. Okay, understanding the requirements is very essential for the testing of the product. You need to understand what the user want you to do in the system for you to be able to test it. Okay. Analysis and planning, test objective and coverage, overall schedule, standard methodologies, resource required, including necessary training, roles and responsibility of the team members, and the tools used. This one is for you to analyze and plan your test. Okay. Test case design and development. You need to identify the component, test specification design, and test specification review. After you do the design, you need to do the review with your team. During the execution, you need to review the code. You need to execute the test and evaluate it, and then based on that, you check the performance of the simulation of the system. Okay. Closure, after you do all the tests, and you need to submit the test summary report, and then the project debrief and project documentation. Okay, that one is after you do all the tests and correct all the error and bugs. Test process analysis done on the report and improving the application performance by implementing new technology and additional features. Okay, based on the test. Different level of testing. We look at the level of testing. We have unit testing, integration testing, system testing, and acceptance testing. Okay. So the first test is the unit testing. This one is the most micro scale of testing, the smallest scale of the testing. So test is done on particular function or codes modules in your system. So that is the unit testing, the smallest testing. It requires knowledge of the internal program design and code done by programmers, okay, not by testers. The programmers are the one, this one is when you do the programs, usually by the programmers. When they write the code, they do the test themselves, okay, the micro testing. They run it, they see whether it's work or not, so on. Okay, so the unit testing is done by programmers. So the objective of unit testing is to test the function of the program or unit of such code as a program or module. Code such as program or module to test the internal logic, to verify internal design. Okay, to test path and condition coverage, to test exception, condition, and error handling. So that is the objective of unit testing. So when it is done, it's when after the modules are coded. So that's why it is done by programmer. After he write the program, write the code, then he do the testing. So he do the test based on the test case just now, or based on the objective. Okay. The input needed for this one is the internal application design, master test plan, and unit test plan. Okay. So it can the output is unit test report. Okay. So that is for unit testing. Who gonna do it? Is the developer or programmer. Method, it can be white box testing techniques, test coverage techniques. So the white box testing technique is where you can do it line by line. Okay, white box meaning that you see what is inside. So you look at the code maybe line by line. The test coverage technique is, for example, if you involve the integer, so you can test the positive, the negative, and the zero. That is the test coverage. Okay. The tools that you can use, you can debug, restructure, code analyzer, path segment coverage tool. This one is the one you do the line by line. Education, testing methodologies, effective use of tools. Okay, this is the training that you can have. Okay. The next testing is the incremental integration testing. Continuous testing of an application as and when a new functionality is added. Application functionality in aspect are required to be independent enough to work separately before completion of development, done by programmer or tester. So this one for the incremental, for the integration testing, it can be done by a programmer or can be done by a tester. Okay. Testing of combined parts of the application to determine the functional correctness. So integration, you correct, you test the function. Okay, so unit test is just now is like the micro part of it, so some tasks or some activities that you need to test. Integration is when you integrate the parts and you do the testing. Parts can be code modules, individual application, client or server application on the network. Okay, type of testing, we just look at this one, is Big Bang testing. So it can be anywhere inside the system, top down, from top to bottom, and bottom up integration testing. So objective of the integration testing is to technically verify proper interfacing between modules and within submodule itself. Okay. So when after modules are unit tested, so meaning that after each unit inside the module is tested, then you combine it and then you do the integration testing. Okay. The input for the integration testing, internal and external application design, that is the document that you can use to do the testing, master test plan and integration test plan. Okay, so when you do this test plan, you need to already have the plan of the test. Okay, output integration test report. After you do all the testing, then you need to come up with the integration test report. Who do the testing is by the developers. Method, you can use the white box, white and black box, problem configuration management, or problem management based on the problems. Okay, because it's integration. The tools, debug, restructure, code analyzer. Again, the education test testing methodologies. This is the knowledge that you need to have to do the testing. Effective use of tools. Okay. So sorry, this one so kecil dekat atas ini. This one is system testing ah. Later I correct it. See atas nih on the top there is a system testing in micro font. Okay. The objective of system testing is to verify that the system components perform control function. To perform inter-system tests to demonstrate that the system performs both functionality and operationally as specified. To perform a type of test relating to transaction flow, installation, reliability, regression, and so on. This test is done after the integration testing. The input needed for you to do the test is you need to have the detailed requirements and external application design. You need to have the master test plan, and you also need to look at the system test plan. And the output or the document that you need to produce after this test is the system test report. Okay. The test is done by the development team and user. Okay, so this is when you include the user when you test the system overall. Okay, when you do the integration and the unit testing, it only involve the developers and the programmers. But when you do the system testing, because you want to test whether the system function as it's required by the user or not, then you involve the user to do the testing with you. Okay. The method that you can use in TICSTAT is the problem and configuration management. The tool is there is a set of tools that you can use. Education is testing method and administrative use of tools. Okay. So, this one, if you look at this one is integration testing. Integration is combining the parts of the system, the module. This one is the system integration testing. So you see whether it can integrate with other system or not. Okay, so that is the difference with integration testing dengan system integration testing. Okay. So the objective of system integration testing is to test the coexistence of products and applications that are required to perform together in the production like operational environment. So you need to look at the hardware, you need to look at the software, the network and the client side, whether it can work or not when you put together everything. Okay, to ensure that the system functions together with all the components of its environment as a total system. To ensure that the system release can be deployed in the current environment. So that is the system integration system testing. When you do the integration system integration is after the system testing, often performed outside of project lifecycle. Okay, so this one is outside, meaning that you are supposed to deliver it, but before you deliver, you do the system integration testing first at the your customer's place. Okay, the output the input, the one you can use to do the integration is the test strategy, master test plan, and system integration test plan. The output is the report you need to produce is the system integration test report. Who do this one? This is when the system tester comes in. Okay. Method, it can be black and white box, problem configuration management, tools, the recommended set of tools, and then the education is testing methodology, effective use of tools. The final one is the acceptance testing. This one is done by the user. Objective is to verify that the system meets the user requirements. Okay, so because you want to verify it meets user requirements, the user is the one who need to do this test. When after the system testing, input the business need and data requirements given by the user at the beginning of the project. So you need to look at that, and based on that, you do the testing. Master test plan, user acceptance test plan. Output is the user acceptance test report. So who do this one is the end user or your client, okay, who gonna use the system. Method, black box techniques, because the user don't have to know what is inside the code. You only know how the system works. So because of you don't have to know what is the code look like, what this code doing. So it's only the black box testing is needed. Methods also problem and configuration management. Tools, compare, keystroke capture, and playback regression testing. So the education testing methodology have a tool, product knowledge, and business release strategy. So this is by user lah. This is the education is the part information or the knowledge that is needed when you do this testing. Okay. We look at the methodologies. So black box, white box, incremental testing, and thread testing. Okay. So black box testing, no knowledge of internal design or code required. Tests are based on requirements and functionalities. Okay, so you only look at the functionalities and the requirements by the user. You don't have to know what is inside, what is the code look like, what is the function do, and so on. Okay, for white box testing, knowledge of the internal program design and code is required. So you need to know what every line is to line of code is doing. Tests are based on coverage of code, statement, branches, path, and condition. Okay, that is white box. Technique for black box testing: incorrect or missing function. Okay, This one is to identify black box testing, identify incorrect or missing function, interface errors, errors in data structure and internet database, performance errors in initialization and termination errors. That is the errors that you can identify using black box testing. Based on requirements and functionalities, not based on any knowledge of internal design of code, because you only do the testing of the outside of it. You don't look at the code. Covers all combined parts of the system. Tests are data driven. So it's based on data. You look at data driven means that you have this data as your input. You expect this data as your output. You only look at the data. You don't look at what happened inside. You only look at your data. If I put this thing, this is my data that I get. So that is why I said it is data driven. Okay. For white box testing, based on the knowledge of internal logic of an application's code. So a white box is the code itself. You need to look at what happened inside. Okay. Based on coverage of code statement, branches, path, condition, and tests are logic driven. Okay, so you need to look at the logic of the code. If this thing happened after you do this, you need to do this, because you need to look at the code. So you need to know, and you need to have the knowledge of what happened after you key in the data. The data is processed like this. The data is saved to this file. The data is like and so on. So you need, that's why it said it's this logic driven. So your data need to be processed logically inside to come out with the correct output. Okay. Functional testing, black box type testing geared to functional requirements of the application, done by testers to check the function. System testing, black box type testing that is based on overall requirement specification, covering all combined part of the system. Okay, and then we have end-to-end testing. Similar to system testing, involve testing of complete application environment in a situation that mimics real-world use. Okay, so it's more or less similar to the system integration testing just now. There is also some other testing, which is sanity testing, initial effort to determine if a new software version is performing well enough to accept for a major testing effort. Okay, regression testing is the retesting of fixes and modification of the software or its environment. Okay, and then we look at acceptance testing is final testing based on specification of the end user or customer. And then we have the load testing, testing an application under heavy loads. Okay, example, testing a website under a range of loads to determine whether when the system response time degraded or fails. Okay, so load testing is like where you ask a lot of users to use it at the same time, to see whether it can complete the task or whether it will fail or not. Okay, that is the load testing. Stress testing under unusually heavy load, similar to the load testing, heavy repetition of certain action or input, input of large numerical values, large complex queries to a database, and so on. Okay, so the stress testing, you do something to stress the system and see how the system react. Some often used interchangeably with load and performance testing. For performance testing, testing how well an application complies to performance requirement. Install and uninstall testing. There's a lot of testing that you need to do. Testing of full, partial, or upgrade install and install process. This one you also need to do, because sometimes how you're gonna do the upgrade or how you're gonna do the project patch, for example. So you need to try do the you also install and uninstall patching and so on. Recovery testing, testing how well a system recovers from crashes, from failures, and so on. Okay. HW is hardware failure. Compatibility testing, testing how well software performs on a particular hardware, software, operating system, environment. Okay, so that is the compatibility testing. You need to test whether it's compatible with the environment you want to use it or not. Okay. exploratory testing, ad hoc testing, informal software test that is not based on formal test plan or test cases. Tester will be learning the software in totality as they test it. And then you have the comparison testing, compare software strength and weaknesses to competing products. Alpha testing, testing done when development is nearing completion. Minor design changes may still be made as a result of such testing. Beta testing, testing when development and testing are essentially completed and final bugs and problems need to be found before release. So the last lah. Mutation testing to determine if a set of data set or the test data or test cases is useful by deliberately introducing various bugs. Okay, this one is mutation. Retesting with original test data to determine if the bugs are detected. Okay, that is the for the testing. Now we look at the white box testing. All independence paths within a module have been exercised at least once. Okay, so in white box testing, if you have a if else case or if you have a if else, if you have a switch, if you have a loop and so on, you need to make sure that each path of your code is tested in the white box testing. Okay, this one is to make sure that all the data is processed correctly. Okay, so for example, like I said just now, if it's supposed to be integer, so make sure that you test the negative value, or you test your zero, or you test your positive value. If you only test the zero and positive and you never test the negative, maybe once in tiba-tiba aja ada value yang needed to make the data be a negative value, you don't know whether there is a error in that part or not because you did not test it. So that's why you need to, when you do the testing, the way you need to do the white box testing is for every path, every route, every code is visited. Okay. Exercise all logical decision on their true and false side. Okay, so if you have um if for example if x equal true, then you do this. Okay, so you need to also if false whether it will do or not, so you need to check. Execute all loops at the boundaries and within the operational bounds. Okay, so the loop, for loop, if there is a boundary cases, if there is a data cases, you need to check. Okay, so like boundary, like I said just now, if it's between positive and negative, the boundary is 0. Okay, that is the boundary cases. Exercise internal data structure to ensure their validity. Internal data structure. Okay, so you need to use all the data, all your information, like I said, every part in the code have to be visited. Okay. This whiteboard technique focuses on validity of the loop construct. Okay, this one is for loop testing. 4 different classes of loop can be defined: simple loop, nested loop, concatenated loops, and unstructured loops. Okay. Other white box techniques is a statement coverage. You need to execute all statements at least once in your code. Decision coverage, execute each decision direction at least once. Condition coverage, execute each decision with all possible outcome at least once. Decision and condition coverage, execute all possible combination of condition outcomes in each decision. And multiple condition coverage, involve each point of entry at least once. Okay, this is an example of statement coverage example. For example, you want to do A plus B. If A equal 3, then B equal X plus Y. And if while A more than 0, do read X, A equal A minus Y, and while do. Okay. So for the decision coverage example, if A less than 10 or A more than 20, then B plus X plus Y. Condition coverage example, it to be uh, for this one you need to cover all of it. Well, or end of file. This one is the statement coverage. You need to go everything. Okay. If this one is decision coverage, there is the decision here. Is it this one or this one? Okay. So this one and this one, or this one and this one. Okay. So there is a decision coverage. Incremental testing, a disciplined method of testing testing the interfaces between unit tested program as well as between system components. So it involves adding unit testing program modules or components one by one and testing each result and combination. Okay, so we already looked at some of this just now. Actually, two types of incremental testing: top down and bottom up. Top down testing from the top of module hierarchy and work down to the bottom. Modules are added in descending hierarchical order. Okay, for bottom up, testing from the bottom of the hierarchy and work up to the top. Modules are added in ascending hierarchical order. Okay, so we look at this testing levels: white box, black box, incremental, and thread. Unit testing is white box. Integration testing is white box and incremental. And system testing is black box. System testing is also black box. Black box testing. Okay. Okay. This one is we talk about automated testing. So we tengok video dulu.
So what does it mean to test your code, and why would you want to do this? You may have heard of developers talk about things like automated testing, but if you don't know what all the hullabaloo is about, then don't worry, we're going to break all that down in this video. So far on this channel, we've touched a little bit of code, but before I go any further, I wanted to take some time and talk about everyone's favorite subject, automated testing. You see, tests as we speak of them are simply scripts that run against our features, our code that we've written. It's a way that we can run through scenarios and see if the results produced are what we expected. When one of those results doesn't match up, it raises a flag and tells us that something isn't right. We call them automated tests because they can easily be run by the computer to quickly run through thousands of scenarios or test cases in a matter of moments. Writing tests for our code is a way to ensure a level of quality and catch bugs before they actually reach our users. We want to ship a stable product that is less prone to breaking, and we also want to have a high confidence that it's working as expected. Shipping large defects in your application can make it really difficult to retain and attract new users, let alone if you're one of the developers tasked with building and maintaining it. So why is this important? Well, broken software isn't just an inconvenience for your users, it's also a fantastic way to lose money. Whether your product is actively generating revenue or not, you'll likely be paying a developer for these fixes to keep your users happy. If you have no testing strategy, it won't give a developer a great insight on what the problem could be. So this means it will take longer to diagnose and remedy a situation, all while you are paying for their time. However, no software is 100% error-free. Different combinations of operating systems, languages, and hardware might produce different results, especially when you're talking about web technology, as we do so much on this channel. Having these in the test situation can show us where the product might need improving and which browsers it might be having trouble with. As a developer, we want to know how the features should behave, and we want to know exactly where to fix the issue when a problem arises. As a manager, you want to catch the defects before they're shipped to our customers for the best experience possible. This is where automated testing can help us. Now, we've used the word testing very generically so far, but there are a few different approaches with our applications as we build them. We can do unit testing, integration, or end-to-end testing. So unit testing refers to the idea of testing an individual piece of code in isolation. In our world of web development, this would be like testing a component. It's a check to ensure whether something works in its standalone environment. This could easily also be a class or just a utility function. For example, let's say we have a web component that renders a user's name and photo. A unit test with this would be like checking aspects of the component, like ensuring the name renders and the photo appears when we feed in the user data. We don't really care about any page it might live on, we just want to know if the component is doing the job it was designed to. End-to-end testing tries to verify a larger set of functionality of the application as a whole. This is often recreating the interactions a user would have when they're driving through the web or mobile application. An example of an end-to-end test would be like clicking the sign in button, entering their credentials, and then navigating to the user dashboard. Something like that nature where we're testing the whole entire flow. They're a good way to check the workflow of critical feature sets. And then there's integration testing, which is testing two or more units together. It's essentially a more complex unit test, so we often don't know the distinction and simply split our tests in terms of unit tests and end-to-end test. Think of an integration test as an in-between of a single given unit versus the entire application. So once these scripts are created, developers can leverage them as they develop new features. As they modify the existing code base, they can ensure they're not breaking or altering the functionality of the app in other areas. Say, for example, we wanted to change a component that is being used in 3 different areas of the app. If each parent component had its own test, we could catch any potential negative side effects from altering that child component. Now you might be sitting there thinking this sounds like a lot of work, and you'd be 100% correct. It is a lot of work. Tests can definitely be challenging to write and maintain in some circumstances. Even then, it does greatly increase the development time and is often a reason people don't do it. A common thought is, well, I'll just push this out now and fix anything that breaks along the way. While this might get you out the door quicker, it's always going to come and bite you later. The application will grow large and failures will become more frequent, and bugs will become increasingly hard to identify. While you will still want an actual person or a QA team to perform a manual check, it's unrealistic to assume that they would catch hundreds of the low-level operating pieces of something like a unit test could. Now that you have a general idea about testing and what different types of testing there are, the next question is usually, well, how much should I test? What should I test? When should I use unit testing? When should I use end-to-end testing? And it's not always a clear-cut answer, as most things are. However, it's usually a good idea to lean heavy on the unit testing at first. This covers your track that pieces of the app are working from a base level, and it's also fairly easy to maintain as the application evolves. End-to-end testing, on the other hand, might be met with some mixed reviews. Remember, this is the one where we actually simulate the user behavior and we drive through the application to find those issues. Well, it's usually well perceived by the product team because it simulates the real user and the application work together as it's intended. If you were to ask most developers, they probably have a different opinion though. Now, it's really cool to see your application zip around like a ghost is using it, but they are increasingly difficult to maintain. And that's because with an end-to-end test, we're querying different areas of the application. For example, let's say we want to check the flow of a login. Well, we're going to go ahead and query the login button. We have to click on that button. We have to do different actions. And if anything changes in our app, like maybe the design of the button, or maybe the button gets removed for something else, it's going to break that end-to-end test. So you'll find when working with these tests, they tend to be a bit more brittle because everything's so tightly coupled together. In a blog post by Google developer Mike Wacker, he describes this very issue and suggests a distribution of 7-20-10 split across your testing suites. So what Mike means here is to keep around 70% of your scripts regulated to unit test, 20% to integration test, so you can figure another 20% into unit test like things, and then 10% into the end-to-end analysis. Now these are just Mike's suggestions, but they are ones I personally endorse. Overall, Mike makes a lot of terrific points and reminds us that there is a point of diminishing returns when we talk about developing these types of scripts. We want to add confidence and reliability, but we also want to deliver updates and focus on our product at a regular pace rather than being consumed and dragged down in test maintenance hell all day. Oftentimes, we need to ask ourselves if the juice is worth the squeeze when it comes to an end-to-end test. So writing tests isn't always easy. It takes patience, discipline, and a commitment from the team to treat as a priority. But if done correctly, it can be tremendously beneficial to everyone from product to engineering. We'll talk about how these efforts fit into a larger picture of quality assurance and a delivery model as we continue to work on this channel. But for now, that's going to do it all for this video. Be sure to like and subscribe to catch more updates like this, and we'll see you in the next one.
Saya tak pasti sama ada saya boleh mengambil.
Okay. Take 10 minutes break, then we continue the last part. Pukul 1 ambil gambar.
Boleh, madam.
Okay. Ada lagi yang belum back tendon ke? Okay. Udah last part, berapa slide lagi ini? 50 slide lagi. So, okay, so we look at okay, boleh nampak tak? Boleh dengar tak? Can you hear me? Halo, halo.
Boleh, madam.
Sekejap connect, sekejap disconnect. Okay, tapi most part dengarkan apa yang saya cakap.
Yes, madam.
Masa dia, masa saya tunjuk. Okay, so we just continue. There is like 50 slide more to go. Ada sejam setengah lagi. Kita nanti ujung some discussion. Okay, so this one we already looked just now. The major testing types is the stress, the performance, recovery, conversion, usability, configuration. Okay. Again, look at the evaluate the system component beyond the limit of specified requirement. There is the stress or the load test. Determines the load under which it fails and how. Okay. So we also want to test what make the system fail. For example, when you do a website, you need to let, like, for example, you what make the system crash, for example. So you need to make the stress. You need to stress the system so that you know if this thing happens, if you do this thing happens. Okay, so that is the load and stress test. Performance, evaluate the compliance, often performed using automated test tools that you see just now, okay, to simulate large number of users. Okay, so the performance test, you can use the automated one, the one that you see in the video just now. Recovery test, confirm that the system recovers from expected and unexpected event without loss of data and functionality. So based on, for example, that the load and the stress test just now, after the system crash or system down, or for example, you have a power failure or anything, you need to test and see whether the data can be recovered or not after that thing happens. Okay. Or if, for example, you have a shortage of disk space, unexpected loss of communication, power outage, and so on. Okay. Conversion, testing of code that is used to convert data from existing system for use in a newly replaced system. Okay. So usually, when the user asks you to do something, usually they already have the old system and they have the old data that they want to convert. Okay, so you conversion test, you also see if you migrate the data from the old system to the new system, whether you can successfully carry the data, or what happened if the data is wrong, and so on. Usability testing, you test the system for the user to learn and use the product. Okay, the user previous testing is the user acceptance. After the user acceptance is usability testing is also part of the acceptance lah. Okay. Configuration examines the application requirements for pre-existing software, initial state, and okay, ada chat apa tadi? Okay, examines an application requirement for pre-existing software, initial states and configuration in order to maintain proper functionalities. Okay, that is configuration. So that is the software testing life cycle phase. Kan already tadi kan. Okay, closure. This one already tadi. Okay, we look at the test plan. Okay. The test plan objective of test plan is to create a set of testing tasks. Okay, assign resources to each testing task, estimate completion time for each testing task, and document testing standard. Okay, alamak. So a document that describes the scope, the approach, the resources, the schedule of the intended test activities. So what you need to identify is the test item, the feature to be tested, the testing task, the task allotment, the risk requiring contingency planning. So that is the document that you need to prepare to do the testing. Purpose of the test plan, to prepare the test plan is to validate the acceptability of the software product, help the people outside the test group to understand why and how the product validate. The test plan should include thorough enough or overall coverage of the test to be conducted and useful and understandable by people outside and inside of the test group. Okay, so that is your test plan. The scope, the areas to be tested by the quality assurance team specifies the area which are out of scope, for example, the screen, the database, the mainframe processes, and so on. Test approaches, details on how the testing is to be performed. Any specific strategy is to be followed for testing. Okay, so that is the approach that you can use, including the configuration management. Entry criteria, various steps to be performed before the start of the test. For example, the prerequisite. For example, timely environment set up, starting the web server or app server, successful implementation of the latest build, and so on. Okay, so that is the entry criteria. Resources is the list of people involved in the project and their designated as host. Okay. Task and responsibility. Task to be performed and responsibility assigned to the various team members. Exit criteria. If you have the entry criteria, you need to also have the exit criteria. contains tasks like bringing down the system server, restoring system to pretest environment, and database refresh and so on. Okay. Schedule and milestone deals with the final delivery date and the various milestone dates. Hardware and software requirements, detail of the PC servers required to install the application or perform the testing, specific software to get the application running or to connect to the database, risk and mitigation plan. These are the possible risks during testing, mitigation plans to implement in case the risk actually turns out to be reality. Okay. Tools to be used, list of testing tools and utilities, win runner, load runner, test director, and so on. Deliverables, various deliverables due to the client at various points of time. It can be daily, it can be weekly, start of the project and the end of the project. This includes test plan, test procedure, test metrics, status report, test script, and so on. Okay. So the reference for you to do the testing, this is the thing that you can refer to when you do the testing. The procedure, the templates. The template is the client specific or otherwise. Depends on whether specified by your clients or your team yourself do it. Standard and guidelines, for example, preview project related documents. So all the document project related. Okay, so this is all the reference that you can use to do your test cases. Okay. Lecture link to the document which will be used to course for testing. Example template used for report test cases. Reference document can also be attached here. So this document you can attach to your sign off mutual agreement between the client and the quality assurance team. Both lead managers signing the agreement on the test plan. Okay, so you make to agree because do the agreement, because if you do the test plan, for example, you want to do the migration test plan, you want to do the user acceptance, you need to involve the user, the client. So that's why you need to include it in your agreement. Okay. A good test plan is developed and reviewed early. Clear, complete, and specific. Specify tangible deliverables that can be inspected, and staff knows what to expect and when to expect it. That is a good test plan. It is also realistic quality levels for goals, include time for planning, can be monitored and updated, include user responsibilities based on past experience and recognize learning curves. Okay, so test cases is defined as test case is defined as a set of test input, execution condition, and expected result developed for a particular objective. Okay, so that is the test cases. Documentation specifying input, predicted result, and a set of execution condition for a test system. I think all of you already did this one in your FYP2. Okay. So specific input that will be tried, and the procedure that will be followed when the software tested. Sequence of one or more subtests executed as a sequence as the outcome or final state of one subtest in the input and initial state of the next. They specify the pretest state of the AUT and its environment, the test input or condition, and the expected result specified what AUT should produce from the test input. Okay. Good test plan, develop and review early, clear, complete, and specific. Specifies tangible deliverables and can be inspected. And staff knows what to expect. It's a good test plan. Balik sini. Okay, so for each test cases, okay. So each test, for your test cases, test plan referred ID, you need to have ID for each your test plan. The test case itself, the test condition, the expected behavior. So the test condition can be the input, output, and expected output that you have, that you expect the system to produce. Okay. Good test cases can find defects. Okay, have high probability of finding new defect, unambiguous tangible result that can be inspected, repeatable and predictable. So good test cases is traceable to requirements or design document, push system to its limits. So this one is for stress and loads testing. Execution and tracking can be automated and do not mislead, okay, and feasible. Defect life cycle, if you have a defect in your system, a defect is a variance from a desired product attribute. Two categories of defect are variance from product specification and variance from customer user expectation. Okay. For variance from product specification, product builds varies from the product specified. Okay, so the user asks you to do something, but this product that you come up with is different. Variance from user customer specification, specification by user not in the built product, but something not specified has been included. Okay, so that is the variant, the difference, okay, in the specification from the user. Defect category, you have three defect categories. The wrong defect, the specification has been implemented incorrectly. The missing defect is specified requirement is not in the built product. The extra defect is the requirement incorporated into the product that was not specified. Okay. You will need a defect log, defect ID numbers. You need to record all the defects. Okay. This descriptive defect name and type, source of defect, test case and other source. So defect usually you can detect it during when you do the testing. So if you detect the defect using testing, you need test cases. Okay. So defect severity, defect priority, and defect status, whether it's new, open, fixed, close, reopen, or reject. Okay. Date and time of tracking for either the most recent status change or each change in the status. Detailed description, including the step necessary to reproduce the defect. Components or program where defect was found. Screen prints, logs that will aid the developer to resolve the problem. Stage of origination. Person assigned to research and to correct the defects. So this is all the information that you need to put in the defect log. Okay. Severity versus priority, which one you should look into? Severity is the factor that shows how bad the defect is and the impact it has on the product. The priority is based upon input from user regarding which defects are the most important to them and must be fixed first. Okay, so that is the severity and priority defects. Severity level, you have critical, you have major, you have average, minor, and cosmetic defects. Okay, so for the critical severity, an installation process which does not load a component, for example, it's severe. Okay, they're supposed to install, but it doesn't install what it's supposed to do. A missing menu option, that is also if you don't have a menu in the code, you cannot do anything. Security permission required to access function under test. The functionality does not permit for further testing. Okay, that is critical. Runtime errors like JavaScript errors, functionality miss out, incorrect implementation, for example, major deviation from the requirements, performance issue specified by client, browser incompatibility and operating system incompatibility issues depending on impact and error or the dead links. If you have supposed to have the link that but it's not working. Okay, so that is some of the severe critical level. Okay, for major level, reboot the system, the wrong field being updated, the updated operation that fails to complete, performance issue, mandatory validation for mandatory fields. Okay, some functionalities incorrectly implemented, image or graphic missing under hinders functionalities, front end homepage alignment issue, severity level leverage medium, incorrect missing hotkey operation, for example. So that is this one is major or high impact table of defect. For minor or low, misspell or ungrammatically text, inappropriate or incorrect formatting, such as font, size, alignment, color, and so on. Screen layout issues. Okay, spelling mistake and grammatical mistake and documentation error. This one is minor lah. Okay, page title missing, old text, alternate text for image, background color for the page other than home page, default value, cursor set focus, image, graphic missing, and so on. Does not hinder the functionality. The test report, you need to come up with the 8 interim reports, functional testing status, functional working timeline, expected versus actual defect detected timeline, defect detected as corrected gap timeline, average age of detected defects by type, defect distribution, relative defect distribution, testing action. Okay, so that is the interim report being produced. For this one, functional testing status report show percentage of the function that are fully tested, tested with open defects and not tested. Okay, function working timeline report shows the actual plan to have all function versus the current status of function working. Line graph is the ideal format for this one. Expected versus actual defects detected, analysis between the number of defects being generated against the expected number of defects, expected from the planning stage. The line graph format that shows the number of defects uncovered versus the number of defects being corrected and accepted by the testing group. Average age, data average defect detected with correction gap. This one is the line format. Average days of outstanding defect by its severity type and level. The planning stage provide acceptable open days for defect type. Okay. Distribution shows defect distribution by function or module and the number of tests completed. Relative defect distribution is normalized the level of defect with the previous report generated. Normalizing over the number of function or lines of code show a more accurate level of defects. Okay. And then towards the end, testing action. Report for your testing action, the report should show possible shortfall in testing, number of severity, one defects, and the variety of defects, recurring defects, test behind schedule. Okay, another information that present an accurate testing picture. Okay, now we look at the testing in critical system. This is the last slide.
Assalamualaikum. We are from group testing safety critical Rizati as the
This
presenter,
is a student
Afi as
presentation.
presenter, I, and Muhammad. Safety critical systems is a system whose failure or malfunction can severely harm people's lives, environment, or equipment. It is widely used in several fields such as medicine, transport, aviation, industrial simulation, and etc. This also consists of hardware and software, and both of them need to be secure to ensure the whole system is secure. Next is the definition. It is used all part of existing legacy software testing techniques. In addition to the existing testing techniques, we have to supplement some special techniques in order to minimize the risk and hazard associated with safety of software and environment. The beside are the quotes from the Lauren. When testing software at different stages of its development, tests are always performed to verify correct behavior against specifications, not against observed behavior. Next is process involved.
In process involved, the testing, safety, and critical system, there are two important factors that distinguish legacy software testing techniques from safety critical testing techniques, which are the degree of rigor and organizational structure. The degree of rigor is the amount of formality involved in testing a system, and organizational structure is the independent verification, which is required in the systems by means of a separate team within the overall project, or a verification team supplied by an external company who may not ever see the development team. Depending on the criticality of the system, there are three techniques, which is the probabilistic risk assessments, PRA, failure modes and effect analysis, FMEA, and fault tree analysis, FTA. First, we look at probabilistic risk assessments, PRA. PRA is a systematic methodology to evaluate risks associated with a complex engineering technologies entity, such as airliner, or a nuclear power plants. In PRA, we need to perform a primary hazard analysis to find out the predefined hazard on safety critical system. The severity levels can be classified as catastrophic, hazardous, major, minor, and not safety related. And the probability of occurrence can be classified as probable, remote, extremely remote, and extremely probable. And the assessment of risk is calculated by combining both impact and probability of occurrence in metrics. Next, the figure shows the process for probabilistic risk assessments until the decision making. Next, we'll present about the failure modes and effect analysis, FMEA.
So the next techniques for testing and verifying safety critical system, which is FMEA, failure modes and effect analysis. This is a procedure for analysis of potential failure in a system for classification by severity or determination of the effects of this failure on the system. And this FMEA can be defined as any errors in a process, design, or item, especially those that affect the customer and can be potential or actual. And effect analysis refer to studying the consequence of this failure. Failure modes, effects, and criticality analysis, FMEA, is an extension to this procedure, which includes criticality analysis used to chart the probability of failure against the severity of the consequence. So the bottom have, on the left, we have FMEA roadmap, and on the right side, we have potential causes and their effects. And next, we have the third techniques for testing and verifying safety critical system, which is FTA, fault tree analysis. FTA is a graphical techniques that provide a systematic description of the combination of possible occurrences in a system, which can result in as a failure. And this undesired effects is taken as a root of the tree of logic. Each situation that could cause the effect is added to the tree as a logic expression, and the events are labeled with actual numbers about the failure probability. And the probability of the top level event can be determined using mathematical techniques. And why we should use the FTA? FTA can be used to understand the logic leading to the top event, show compliance with the system safety, prioritize the contributor leading to the top event, monitor and control the safety performance, minimize and optimize resources, assist in designing a system, function as a diagnostic tool to identify and correct causes of the top event. Next. So this is one of the example of FTA. Here we have the failure event A as a top level failure event. This is a broken down, it will broken down into possible contributory failure events. And under it we have OR symbol, means that event A happened when one or more event B, C, or D happens. And then failure event D, we have under it we have N symbol, means that event D happens only when both event E and event F happens. Next. So this is the second example. The failure for this, we have the doorbell failed to ring. And for this example, we have only the or symbol. Next, I will pass to the next presenter.
Okay, now I will present about the case study. This case study is about failure modes and effect analysis and fault tree analysis based. Sorry. This case study is about failure modes and effect analysis and fault tree based software safety analysis of a railroad crossing critical system. The software is hazardous if it can cause a hazard that cause the other components to become hazardous, or if it is used to control a hazard. Software is deemed safe if it is impossible or at least highly unlikely that the software could ever produce an output that would cause a catastrophic event for the system that the software controls. None of the fault removal techniques like algorithm analysis, control flow analysis, pattern analysis, reliability diagrams, need circuit analysis, inventory analysis, ITMEA and FTA can be considered appropriate and complete in all respects when used in isolation. The way out of this is to analyze how to combine individual techniques so that the fault removal process is significantly improved. One of the most effective combination is failure modes and effect analysis FMEA and fault tree analysis FTA. This paper proposed a system-level approach to software safety analysis for critical systems that combines two existing fault removal techniques, failure mode and effect analysis and FTA, to identify and eventually remove software faults at successive software development phases. So next, I will pass to the next presenter.
Thank you, Muhammad Imran and other presenter. I will continue Muhammad Imran present about the ROCS. Sorry for the spelling mistake here. For the RCCS software function, the safety analysis of RCCS software function takes place in three sequential steps. The first step is software failure mode and effect analysis, SFMEA. This analysis is performed in order to determine the top events for lower level analysis. SFMEA will be used to identify critical functions based on the applicable software specification. The second step is software fault tree analysis, SFTA. After determining the top level failure events, a complete software fault tree analysis shall be performed to analyze the faults that can cause those failure. This is a top-down technique that determines the origin of the critical failure. And the last sequential step is evaluation of results. The evaluations of the results will be performed after the above two steps in order to highlight the potential discrepancies and prepare the recommended corrective measure. Next. Here we have an example of SFMEA tables for the RCCS. The failure mode here is gate not closed as train is passing through, and the possible cause is sensor not detected by software. Gate motor mechanism is defective, software give wrong command, and lastly software give right command at wrong time. The effect of this failure mode is train collision with passing road traffic leading to accidents. The severity of risk for this failure mode is critical, and the prevention and compensation is software first checks the working status of gates each time the train is about to cross the gates. Next. Here we have the software fault tree analysis. As we can see here, in this fault tree analysis, all the event is OR, and as we know, the possible cause for this event is sensor not detect, and it happen when sensor broken or the train sensor interface disconnect. That's all from our group. Thank you.
Okay.
Assalamualaikum. We are from.
So that is on testing. I think everyone get ready for the picture already. Can everyone turn on your camera? Yeah. Capture screen, please. Can you turn on the camera? We ambil gambar sekejap. And then we continue watching. I just play video. Because actually I have to finish at 2. But I already finished. So I just play some video and verification and so on. You just watch lah until the end. After nearly 2 years dekat apa? From last year, this year, diam dekat rumah kan. Yang lelaki semua nampak rambut panjang serabai.
Begitulah, madam. Begitulah.
Itulah. My son dekat rumah pun rambut sudah macam perempuan sudah. Kita tunggu ramai lagi turn on nanti.
Ni salam kereta, Anis.
Saya dalam kereta. Semua bagus line kah? Lagi dan lagi.
Baguslah Lestra pakai mask.
Fufu tiup dia. Kerja kah, Listra?
Pak macam di fakulti je
Faculty kah? So kesian korang kan? Nak grade tak balik, dapat balik campus, so kesian. Harap combo dapat balik lah nanti.
So sad, madam. So sad.
Ya, so kesian. How long? 1 year kan tak balik? 1 year, 2 semester kan? 2 ke 3 sudah?
I think 3 semester.
3 semester, ya. Yes, at least nak grade tak dapat masuk. Yang baru nak start tu, second year sudah. Tak dapat masuk lagi.
Just imagine, madam, 4 years. Dia tak dapat masuk uni mas.
Yalah, nama je ini mas student. Okay. Kejap saya print screen Kejap, mana button?
Listra buka mas, Listra.
Buka mas, ambil gambar. Kejap saya try. Mana saya punya print screen? Print screen, alternate kan? Alternate ke? Cubalah. Okay. Kejap Save screenshot to OneDrive. Sekejap lagi. Sekali. 1. Tangan saya kat sini. 1, 2. Okay. Lagi saya pergi next page. Next page tak ramai orang yang turn on. Okay. I just capture lah. Yang lain tu dia tak on. I just capture the name. Ya. Anis dalam kereta tengah menyanyi ke?
Bukan.
Okay, hi everyone. Lama tak nampak. Nanti dah graduate. Siapa yang dah kerja? Ada yang dah kerja?
Listra.
Listra dah kerja dekat office. Kerja kan Listra? Ya, I can hear you. Boleh dengar?
Boleh dengar ke, madam?
Boleh, sikit.
Kerja dah dekat fakulti.
Kerja dekat faculty? Cannot hear. So untuk yang lecture dah habis. So untuk yang ni, I just play video lah. So you just watch video on verification and validation lah. You just continue, okay? Jangan left meeting dulu. Jangan left dulu.
Alright, madam. Thank you.
Jangan left
Wih,
dulu.
laju.
Laju. Betul keluar terus. Okay. Okay, can turn off your video lah. Bye. See you later. Just watch the video lah untuk yang tu. On more on verification and validation lah. Okay. Saya cari video.
Minggi, tutup kamera Minggi.
Boleh je on. Tengok-tengok. Saya share this one. Semangat orang ni.
But Grammarly can help. This sentence is grammatically correct, but
Verification and validation. Hi guys, welcome you all to my YouTube channel Software Testing by MKT. As a part of this video, I'm going to talk about difference between verification and validation. Before I proceed with this video, make sure that you guys have seen my VNV model video and stages of requirement video. Link is there in the description. Please check it out. Those two videos will help you to understand the difference between verification and validation in a very perfect way. So, before wasting time, let's get started to talk about what are the main differences we have for verification and validation. So, talking about verification, you're verifying customer requirement specification, your software requirement specification, your functional specification, your high level design, your low level design, verifying CRS, SRS, HLD, LLD, whether it is according to the requirement or not is called as your verification. Talking about your validation, testing the function by executing test cases. So this is one of the major difference between your verification and your validation. Your execution of code does not come under your verification activity. Your execution of code comes under your validation activity. Your verification activity is usually done by developers. Your validation activity is usually done by testers. When I talk about what are the things that we actually do in verification activities are walkthrough, meetings and inspection. When I talk about walkthrough, I mean they go through the code that developer has written. They go through the high level design and low level design, and from low level design to coding, how developer has done, they verify all those things. They also do inspection to check whether each and everything while converting from customer requirement specification to software requirement specification, from software requirement specification to high level design, low level design, and then finally coding is happening exactly perfectly fine or not. These are all activities take place in your verification, and the activities that take place in your validation are white box testing and black box testing. Out of your verification and validation, the first thing that takes place is your verification, and the second thing that takes place is your validation. Because first thing you will test whether your requirement is correct or not, whether while converting your document to your design, and then finally coding is working perfectly fine or not. That is a part of verification. So your verification takes place first before your validation activity. In validation, you just test the application. Cost of fixing the defect in verification is usually less when compared to cost of fixing any defect or error in your validation. The reason I'm telling cost of fixing a defect is less in verification is because it is just the document from customer requirement specification that we have converted to software requirement specification. If any mistake is there, if any error is there, cost of fixing the defect is very less. You will just go through the document and you will just correct it. So cost of fixing the defect is very less. When I talk about your validation activity, developer has given the code to the tester. Now tester is actually testing the application by executing your test cases. If he found any defect, he will raise a bug and give it to the developer. Now developer has to fix it again. He need to do white box testing. Then again he will give it to the tester. Now tester has to test it and verify that bug is fixed or not. And because of that bug, is it impacting other feature present in my application or not? So that is the reason we say that cost of fixing the defect in validation is more compared to cost of fixing the defect in your verification activity. And the things that are evaluated in your verification activities are your customer requirement specification, software requirement specification, your high level design, your low level design, your code, and sometimes even test cases. And the things that we actually test or that are actually evaluated in your validation activities are generally the software. And the main aim of your verification activity is to make sure that are we building the product in a right way. It is that product which is not yet developed. We need to make sure that what is the product we are going to build or develop, are we building in a product in a right way or not? That is one of the main important topics.
What's up, everybody? How's it going? This video is going to be one of my most fun and interesting ones yet. We're going to be looking at 3 real software engineering bugs. These are 3 bugs that we encountered on AlgoExpert, my company, my website, algoexpert.io, and I think that whether or not you're a software engineer, in other words, maybe you're someone who's never written a line of code in your life, I think that you'll be able to appreciate this video because it's going to give you a glimpse of what happens behind the scenes of a real product. What kinds of bugs can introduce themselves in real products, how they manifest themselves, and how we as software engineers can kind of debug these bugs. I picked these 3 particular bugs specifically to show you various flavors of bugs. As you'll soon see, these 3 bugs are quite different from one another. The first bug is the type of bug that's just caused by errors in your code, and you have to kind of find the errors. The second bug is much more of a hairbender. It's the kind of bug that involves both the front end and the back end, and it's just much more difficult to find its root cause. And then the third and final bug is probably the nastiest type of bug. It's the kind of bug that is completely mind-numbing, where you have no idea what's going on, you cannot find the answer, and finally you realize that the fix is just a one-line fix that still doesn't really make sense and is still kind of incomprehensible. So be sure to stick around for that last bug. With that, let's dive into it. So for the first bug, I'm actually going to cheat a little bit, and I'm going to group a bunch of bugs into one. Basically, when we started developing AlgoExpert, we had a lot of bugs affecting the questions list page on AlgoExpert that you can see right here. By the way, if you're thinking right now, is this entire video some sort of ingenious hidden ad for AlgoExpert? You'd be right. Now, if you're not in the business of preparing for coding interviews, you are not the target audience of this ad, and you can continue to enjoy the content of the video. But if you are in the business of preparing for coding interviews, then, by all means, check out algoexpert.io, use the promo code CLEM, C-L-E-M, for a discount on the platform, and then continue to enjoy the content of this video. Now, where was I? If you go back on the questions list page, you'll notice that one of the key sort of functionalities that we have on this page is we give users the ability to reorder their questions and to save their new questions order. So for instance, I can move this linked list construction question here. I can move this BST construction question right here. I can move this question here, right? You have this sort of like nice little thing to kind of reorder questions. And if you refresh the page, you can see linked list construction here is at the top of the easy category. We'll refresh, and it's still at the top. Now, here are some of the bugs that we had on this page. One of the recurring bugs that we had was that we were incorrectly storing data about the order of questions, and so basically we weren't saving the order of questions. So for instance, if I move this question, iterative in-order traversal, I move it to the top, it says saving, and then we refresh, and yet it's still at the bottom, so it didn't save. Another bug that we had, kind of a funky one related to CSS, was when you would drag a question, sometimes it would go underneath other questions. Sometimes it would go above, sometimes it would go underneath. Right? Super funky. You can see it's sort of hovering underneath other questions. Now this was just that we were incorrectly setting the z-index attribute in CSS, which kind of says how high in space an element is, and we were incorrectly doing that, but kind of a weird, gnarly bug, so to speak. Yet another bug that we had on this page was with this group randomly feature that we recently came out with. As you can see here, we're grouping the questions not by category, not by difficulty, just in a seemingly random order, but as you might imagine, behind the scenes, we are keeping track of these sort of 4 different columns here, and we are making sure that they're all positioned in the same position every time. Now, we were incorrectly sort of sorting these 4 columns and keeping them in their correct order, so when we would reorder questions, like look, if I reorder them, see how the columns swap? And this would happen sometimes because, again, we were incorrectly sorting these sort of 4 columns. And so as you saw, all of the bugs that affected this page were really bugs caused by our code. We just had to kind of sit down, dive into the code, and fix them. So the second bug that I want to show you is this one. And this one dates back to a couple of years ago now. It was at the very beginning of AlgoExpert when we were first developing the platform. And I don't believe that this bug found its way to production. I do think that we caught it as we were developing AlgoExpert. But so basically, when you go on the purchase page of AlgoExpert, if you scroll down and you want to try to actually buy the product, you can just fill out your information. So I'll put foobar here. I'll put a random test credit card. This is on my local dev server. This will not work on production. But so if you purchase AlgoExpert, you wait for the sort of request to complete, and then you are met with this little success message that tells you, woohoo, your purchase worked, and you can start working. Now, when you click this Start Working link, you would expect to have access to the product, right? And yet, lo and behold, you're on the questions list page, and all of the questions that were inaccessible before you purchased are still inaccessible. And this is really bad, right? You literally can't click on the questions. You just don't have access. At the top, you can clearly see it says you don't own AlgoExpert. So this is a really bad bug. Now, it's not quite as bad as you think, because if you refresh the page, ta-da, you do have access. Now you own Algo Expert and all the questions are available. But so what is going on here? Why is it, and this was what we were asking ourselves when we were developing this and kind of encountering this bug, why is it that we purchase the product, clearly we get, a success response from our backend that tells us, yeah, you purchased the product, everything worked. You go on the questions list page, you don't have access, but when you refresh, you do have access. So we started asking ourselves, what happens when you first load Algo Expert, which is what we were doing when we refreshed the page, that we don't do right after purchasing. And we were kind of trying to find the discrepancies and, the things that could cause this issue. And basically what it turned out to be, and this is why earlier when I introduced these bugs, I said that this one was kind of a hairbender because it was both the front end and the back end, is when you purchase Algo Expert, we make a request to our backend. We hit the Algo Expert API. Our API then makes a request to Stripe, our payment provider. Now, Stripe does a lot of sort of magic behind the scenes. It contacts your bank and it does stuff with your credit card to make sure it's not fraudulent and all that good stuff. And what it does takes too long of a time for it to keep connection with the client, if that makes sense. So basically, once the request sort of completes and we're told by Stripe that things are good, right? This card is not fraudulent or whatever, and we've completed the charge. But before they've sort of validated, I guess, everything with the bank, by the way, I'm kind of explaining this here, probably leaving out a couple of details. But so basically, when Stripe finally knows that, hey, this user, everything worked, and they now have access to the product, we have updated their sort of account status to have access to the product, it is no longer speaking to the front end or to the client. And Stripe can't just magically reach the front end or the client, the browser, right? The browser has to sort of re-ask Stripe, hey, does this user have access to Algo Expert? And so here, that was sort of the issue. We needed to make another call on the front end to Stripe that sort of said like, hey, Stripe, tell us the status of the user. This happens to be a call that we make on the front end when you load the page, but we didn't make it right after you purchased Algo Expert. And I can even show you the exact place in the code where we implemented the fix for this bug. It's right here in the middle of all of our code to purchase Algo Expert. You'll notice that basically we have this thing here, subscribe to plan. This is sort of the method that calls the backend and does all the purchasing. And then finally here, when everything has succeeded, we have to call this method here called force Stripe hook. And if we look at what this method is, well, here I added a line, return promise.resolve, which basically made this method not do anything, and I did that so that I could demonstrate the bug to you all before. So basically, this calls this getStripe substatus method, which does exactly what I was saying earlier. It sort of reissues a call to Stripe and says, hey Stripe, tell us about this person's subscription status. Do they have access to the product? And you can see here we have this comment that kind of explains why are we doing this seemingly weird call to Stripe after we've purchased the product. So that was the second bug. Now let's look at that third and final bug, which, like I said, was mind-numbing. So this third bug was actually live in production for about a month, and it happened pretty recently, about 2 months before I'm posting this video in the summer of 2019, and it affected the coding workspace on Algo Expert, what you're seeing right here. Now, if you're familiar with the website, you know that this is one of the sort of bread and butter features of the website. It's a key part of the website. And we started getting customer complaints saying that the entire coding workspace was kind of laggy. There were sort of performance issues, it was a bit choppy, just wasn't a great experience. Now, this was super concerning for us because, first of all, you never want to hear about performance issues when you're dealing with front ends. That's just a very bad thing to hear about. And second of all, we had never had any issues with performance during the first, year and a half of Algo Expert's lifespan. And so when we heard about this, we started looking into it and we realized, wow, we can actually replicate this. And so I'm going to show you what it was. You might not be able to see the actual lag on the entire workspace in the recording because the entire workspace was sort of laggy. But if you look at one of the sort of code editors, let's look at the test one right here. I'm going to zoom into it. You can see that if I scroll down, you see how it sort of jumps? Like I'm scrolling down and you see how the sort of test cases just like randomly jump? That's such a bad experience. It's super janky. It's sort of out of nowhere. It makes it hard to kind of scroll through the inputs. That was happening in all of our input editors. The entire workspace was just sort of laggy. Not that laggy, but laggy enough to where it was noticeable. And so we started getting really concerned. What was causing this? So as we started debugging this issue, the first thing that came to our minds was that maybe we had too many of these text editor boxes on the page. As you can see, we have one for the prompt, we have one for the hints, we have one for the output, for the solutions, for the tests, and behind the scenes, we're using a library called CodeMirror. It's an open source library, something very popular. It's probably the best library for code editors and for text editors. It gives you, for instance, these colored keywords for languages like JavaScript and Python and so on and so forth for free. But so we were wondering, maybe we have too many of those on the page and that's somehow causing a performance issue. Now, we were really hoping that that wasn't the issue because that would have been really bad. That would have meant that we would probably have to rethink our page, right? Maybe we wouldn't be able to have all of these CodeMirror editors on the page. But so what we did is we started removing one by one these editors. Now, it's unfortunately not as easy as just deleting a block of code because there's so much going on into this page where we feed so many, parts of data and everything to different front-end components, and if you try to just delete a block of code, you get a bunch of errors. But we eventually did it. We removed editor by editor, one by one, and the performance issues were still there. They were not being fixed. And we also, of course, confirmed that the performance issues were nowhere to be seen elsewhere on the website. If we removed the entire editor workspace, like all 5 of these boxes, then there were no performance issues. So we knew that it had something to do with the boxes, but it wasn't how many boxes there were. So it was really confusing. And then finally, we found out what the issue was, and to this day, we still don't understand why this actually fixed this bug, but we just found one super vague, super sketchy Stack Overflow answer on this, and wait for it. Wait until you see what was causing this terrible performance bug. It's a one-line CSS fix, okay? Ready? Literally this one line here, line 9, where we added a border radius to all of the elements with the CodeMirror class on the page. So these are the 5 CodeMirror editor boxes. And for those of you who are unfamiliar with border radius, this seems absolutely benign. Border radius just literally curves the edges of your border. So for instance, here, if you put 4 pixels, it basically just says, oh, you'll have one corner of your box that's going to have a slightly rounded edge. For whatever reason, this is where you literally want to pull your hair out. This border radius is what was causing the issue. And I can show you, if I comment out this line and we save, and I go back to the workspace, now if I scroll, it just works. There's no jumpiness, no jankiness, no nothing. The entire workspace is now performing as it should. There's no lag. And that one line somehow fixed the entire bug. So those are 3 of the many bugs that we've encountered on AlgoExpert. I really hope that you enjoyed seeing them in their full glory. If you did, let me know in the comments below. And let me know, by the way, if you liked this kind of video and if you'd like to see more bugs or more stuff like this. I'd love to know. Don't forget to destroy the like button, to subscribe if you haven't already, to turn on that notification bell so that you know when I post. And I will see you in the next video.
One last video. 7 testing.
Grammarly does more than catch errors. With Grammarly, you can find
Rights to paste the file in folder B. Folder B is on a shared drive and storage capacity is full. Folder B already has a file with the same name. In fact, the list is endless. Or suppose you have 15 input fields to test, each having 5 possible values. The number of combinations to be tested would be 5 raised to 15. If you were to test all the possible combinations, project execution time and costs will rise exponentially. Hence, one of the testing principles states that exhaustive testing is not possible. Instead, we need the optimal amount of testing based on the risk assessment of the application. And the million-dollar question is, how do you determine this risk? To answer this, let's do an exercise. In your opinion, which operation is most likely to cause your operating system to fail? I'm sure most of you would have guessed opening 10 heavy graphics applications all at the same time. So if you were testing this operating system, you would realize that defects are likely to be found in a multitasking module, and that needs to be tested thoroughly. Which brings us to our next principle, defect clustering, which states that a small number of modules contain most of the defects detected. With experience, you can identify such risky modules. But this approach has its own problems. If the same tests are repeated over and over again, eventually the same test cases will no longer find new bugs. This is another principle of testing called pesticide paradox. To overcome this, the test cases need to be regularly reviewed and revised, adding new and different test cases to help find more defects. But even after all this sweat and hard work in testing, you can never claim your product is bug-free. To drive home this point, let's see this video of the public launch of Windows 98.
Let's plug it in. It's going to say, hey, I see you plugged in a new device, and it's going to load in the appropriate drivers. You'll notice that this scanner build... Whoa. Moving right along.
That must be why we're not shipping Windows 98 yet.
You would think a company like Microsoft would have tested their OS thoroughly and would not risk their reputation just to see their OS crashing during its public launch. Hence, the testing principle states that testing shows the presence of defects. Testing reduces the probability of undiscovered defects remaining in the software. But even if no defects are found, it is not a proof of correctness or a proof that no defects remain in the system. But what if you work extra hard, taking all precaution and making sure your software product is 99% bug-free and the software does not meet the needs and requirements of the client? Which leads us to our next principle, which states that absence of error is a fallacy. Finding and fixing defects does not help if the system build is unusable and does not fulfill the user's needs and requirements. To fix this problem, the next principle of testing, early testing, states that testing should start as early as possible in the software development lifecycle, so that any defects in the requirements or design phase are captured as well. We'll have more on this principle in a later tutorial. And the last principle of testing states that the testing is context dependent, which basically means that the way you test an e-commerce site will be different from the way you test a commercial off-the-shelf application. Before we close this tutorial, here's a quick recap of the 7 testing principles.
Oke, so itu sahaja untuk hari ini. Apa lagi yang belum ada attendance, ada tak? Oke, so itu saja. Bye guys. No question kan? Good luck to everyone.
No, madam.
Congratulations, sudah great.
Thank you.
Okay, congrats all. See you around. Jumpa masa konvo. Hopefully dapat balik ini mas.
Hopefully, madam. Hopefully.
Yeah, okay. Bye guys.
Bye, guys. Madam. Take care, madam.
Okay, thanks, Ramadhan. Christopher Chi bagi nombor matrix. Nanti saya do manually. 6055. Okay. So. Okay, done, Christopher. Sembilan 408. Okay, any more attendance? Tak ada lagi kan? Oh dah. Abdul Rahman dah.